meeting you once again. So we will start the live streaming. Ankit, you're ready to do the live streaming right now?
Oh, I am just setting it up. Yeah.
Yeah, you can also start sharing the link of YouTube so that people who wish to watch us on YouTube can watch us live on YouTube. And I think Dr. V.R. Sharma is yet to join. So Ankit, Pradipta, once again, Ms. Bhatnagar ji, namaskar and a warm welcome to you.
नमस्कार भैया, बहुत बढ़िया. I am very grateful to you. आपने हमारे को इतना सम्मान दिया कि आपने 5 बजे के पहले मेरा नंबर डाल दिया क्यों में. So kind of you.
You are our senior most speaker today. So all regards to you. You are 78, if I'm not mistaken, right? 78.
नहीं सर, 70 इतना मत हमको बुढ़ा बनाइए, बाल नहीं है इबादत. I am 74.
74. Yeah, but still
my passport age.
Perfect. That's what we go by. Your passport age is 74. So you are our senior most speaker today, undoubtedly.
Yes. Don't use the word senior most because there are many senior people here. You say the eldest in age.
Eldest in age is also senior most in experience.
No, senior most like people like V.R. Sharma or ये सब, they are all chairman level people, sir. हम लोग कहाँ अभी? They are very senior.
Yeah, but like, you know, the company designation is not the only you know, sort of introduction for a veteran like you. You have spent years in sale. You have spent years in this industry. And you are the Secretary General of the Pellet Manufacturers Association of India. So you are, in other words, the spokesman for the pellet industry, undoubtedly. So a warm welcome to you, Bhatnagar Sahab, once again.
Thank you. Thank you.
We are just waiting for Mr. V.R. Sharma.
Sure.
So please check once again with Srikant to see Mr. V.R. Sharma if he's ready to join, and we'll get started right away because I think we are exactly at 3:30 right now.
So Mr. V.R. Sharma will be joining in another 5 minutes. So I think maybe we can start with the introductions.
Yeah, you can, with kind permission from Sahuji, Mr. Paul, Dr. Lamke, Mr. Zampa, Mr. Prasad, Mr. Lobo, Indrajit Paul, Andrin, Soikat, please give us permission to start. So Ankit, over to you to start. And by then, Mr. V.R. Sharma can join. So, Mr. Zampa, I take your kind permission also to start because we are at 3:30. Let's not delay and start right away. Ankit, over to you.
Okay, so I thank you very much, first of all. Okay, so I can start. Thank you very much to you for your kind invitation to this webinar and all the other gentlemen that are here. Okay.
Yeah.
Just a brief introduction of myself. I'm working in Danieli since 22 years. Okay.
Oh, great.
I'm working in different fields, and in the last 15 years, I work in the direct reduction plant and beneficiation and pelletizing.
Perfect. So you are a perfect fit for all the three topics we are going to discuss. And Mr. V.R. Sharma, I can see, has already joined. So a warm namaskar and a warm welcome to our keynote speaker, Mr. V.R. Sharma today. Mr. V.R. Sharma needs no introduction. He is the present Vice Chairman of JSPL Advisory Services. Earlier, he was Managing Director of JSPL. Besides, you know, he's a person who has led the industry right from the front, as we say. So, Ankit, over to you to introduce the speakers, and Mr. V.R. Sharma will be our first speaker who will give the keynote address. So over to you, Ankit.
Yeah, so good afternoon, everyone. A warm welcome to all our panelists and the attendees who have joined us today, and also to everyone watching on our live stream on YouTube. We welcome you all to our 50th webinar. So we started doing our webinars back in 2020, and today is our 50th webinar after 3 years. And our webinar is titled Challenges and Opportunities in Iron Ore, DRI and Pelletisation in India. I would like to take this opportunity to welcome our sponsors, our silver sponsors, Haver and Birker and NMDC, as well as our steel sponsor, Kudremok. So thank you for supporting our event. And I would now share my screen to introduce our panelists. So please let me know if my screen is visible.
Yes, it is.
Okay. So our keynote speaker for today is Mr. Vyas Sharma. He is the Vice Chairman, JSP Group Advisory Services Private Limited. Then we have Mr. T. Saminathan, CMD KIOCL Limited. Mr. Anil Kumar Chaudhary, Group CEO, SR Minerals and Metals and ex-chairman SAIL. Unfortunately, I think he will not be able to join us today due to a personal emergency. Then we have
his brother-in-law has been admitted to a hospital with a cardiac arrest and a heart attack. So he has to go to the hospital. Yeah. So Mr. Zampa, yeah.
So yeah, we hope it will be better soon. He will be better soon. Our next panelist, Mr. Massimiliano Zampa, is the Vice President, Engineering and Process Technology, Danelli Centro Metallics. Mr. B. Sahu, ED Production and Coordination, NMDC Limited. Mr. Deepak Bhatnagar, Secretary General, Pellet Manufacturers Association of India. Mr. Jan Lamke, Technology Unit, Pelletisation Manager, Haver and Björkard, Niagara. Dr. Saikat Samanta, AGM Process and Sales, Neufer GmbH. Mr. Priyaranjan Prasad, Managing Director, Brahmani River Pellets Limited. Mr. Indrajit Paul, Chief Pellet Plant, Tata Steel. Mr. Naveen F. Lobo, General Manager, Process Control, Iron Zone, JSW Steel Limited. Mr. Bernard Hibel, Head of Technology and Innovation for Agglomeration and Direct Reduction, Prime Metals Technologies. And Dr. Anwin Bhattacharya, CEO, Resiron, Austria. So these are our panelists for today. I would, before we proceed, there are just the general guidelines for a smooth platform management that I would like to mention. So for all the attendees who have joined us on Zoom to listen to our discussion, we have a Q&A section, which you can access from the bottom of your screen on the Zoom app. On the bottom, you will find a Q&A section. It can also be accessed by all the panelists. And I would request you to post your questions and queries in the Q&A sections, and the panelists can then choose to either answer it live or directly in the chat. I would also request all the panelists to keep their microphones muted when the other panelists are speaking to avoid any kind of noise feedback. And last but not the least, I would request everyone to adhere to the time limit as given in the program to avoid any delays. Today's webinar will be moderated by my father, Mr. Nimalya Mukherjee. So on behalf of Steel and Metallurgy, I would like to welcome you all to this webinar. I would now...
Let me Ankit, just give me a second to grant a warm welcome to our keynote speaker, Mr. Vyas Sharma. Sharma Sahab, once again, a warm welcome. And without the leader, we cannot start. So we all seek your blessings and guidance to start. Ankit, you can move ahead with the national anthem.
Thank you. Namaskar. Namaskar.
And Mr. Vyas Sharma will be our first speaker. Ankit, let's rise for the national anthem.
Everyone to please rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you.
Ankit.
So before we start with the panel, we just have a few corporate videos from our sponsors. So I would now like to display the corporate videos, starting with the video from NMDC.
What do you find when you dig deep into the depths of the earth? We found a few rare elements, like commitment, compassion, a passion for perfection, and a vision for a stronger and better tomorrow. That is NMDC. It's not just a pioneering story of one of the world's finest iron ore producers, but a story of leadership with a human touch. From the depths of the earth to the bottom of hearts, NMDC has touched lives all around, creating wealth, building sustainable opportunities, and working towards impacting lives positively. NMDC, harnessing Earth's goodness.
Our second video is from our silver sponsors, Hover and Booker Niagara.
When you think about leaders in mineral processing technology, when you think of excellence in service throughout the world, think about Hover and Booker Niagara. Since 1872, Hover and Booker Niagara have been a leader in screening, pelletizing, and mineral processing systems. Our mission is to deliver the best of these technologies to customers in the mining, aggregates, minerals, cement, building materials, fertilizer, salt, and recycling industries. But it doesn't stop with excellent products. We serve our clients to maximize their plant's profit, productivity, and proficiency. That's our ProCheck process. How does it work? We examine or ProCheck the potential in key segments of your process to help solve your material handling challenges. Our pulse diagnostic tools monitor your vibrating screens to ensure uptime. With sustainable mineral processing technologies, we work with you to determine the right processing equipment for your application. By analyzing the 3 phases of screening, layered, basic, and sharp, we find the optimal combination of opening and open area to achieve your product specification. We are focused on servicing our customers in all aspects of mineral processing, offering custom parts and service programs for maximum uptime. And through our signature near-flow simulation software, we provide expert process engineering. Hover and Booker has been a trusted name in mineral processing technology for over a century. Our customers partner with us because they know that for us, it's not just about a sale. It's about working together to ensure their plant's profit, productivity, and proficiency. Let's build the world together.
And finally, we have a video from KIOCL.
KIOCL Limited, India's premier pelletizing and pig iron complex. KIOCL Limited, a flagship company under the Ministry of Steel, was established on 2nd April 1976 to mine, beneficiate and export iron ore concentrates from Kudremukh deposits. KIOCL is engaged in the production of iron oxide pellets and foundry-grade pig iron suitable for domestic as well as international markets. The raw material iron ore procured from Bellary region is transported through rail route to its captive railway marshalling yard at the New Mangalore port area. The ore received by rail and ships is stored in two covered storage sheds, each of 2 lakh tons capacity. The iron ore is conveyed to ball mills through silo and bunkers for screening through primary screens, grinding and filtration. Two of the 3 ball mills are operated at a time in a closed-circuit grinding. Each ball mill is maintained at 250 tons per hour feed rate. The ground slurry is then passed through derrick screens for finer separation and pumped to dewatering cyclones. The slurry is then pumped to 2 agitator tanks of 7,500 ton capacity each. The slurry is filtered through vacuum disc filters and also horizontal pressure filters to get filter cake of moisture 11% and 8.5 to 9.5% respectively. The filter cake thus produced is conveyed to the storage shed through a series of conveyors. The filtrate generated during the filtration process is sent to thickener for recovery of water used for various processes. The entire plant operations are controlled through computer control system at port facilities and pellet plant. Additives like bentonite, limestone and coke are ground at the given ratio or mixed with iron ore filter cakes. The mixed material is then conveyed to the day bins. Day bins will feed mixed material to boiling discs, which are inclined at 47 degree with 7.5 meter diameter. The discs can produce 140 to 160 tons of green pellets per hour. These green balls are screened through primary roller screens and then double-decker roller screen to get correct size of 9 to 16 mm. Unsized pellets are sent back for processing. Correct sized green pellets are then fed to the furnace, which has a reaction area of 492 square meters. In the furnace, the pellets are gradually fired up to 1320 degrees Celsius to get the desired physical properties like CCS of about 250 kg per pellet. These pellets are screened for correct size before conveyed to the stockyard through conveyor system. The pellet stockyard can accommodate approximately 2.5 lakh tons. The pellets are loaded through mechanized loading system, which includes boom type reclaimer and ship loader of the capacity of 6,000 tons per hour. A captive iron ore berth has been provided to handle ships of 65,000 dry weight ton with loaded draught of 12.5 meter. With the provision of an exclusive berth, waiting time for ships is eliminated. KIOCL has installed captive power plant consisting of 3 diesel generator sets of 9.36 megawatt capacity each, using furnace oil as fuel at pellet plant, and 7 megawatt captive power plant at blast furnace unit, which uses surplus blast furnace gas. The pig iron complex was commissioned in February 2001 with an annual capacity for production of around 2.16 lakh tons of pig iron. Today, KIOCL is capable of producing pellets both in hematite and magnetite as a result of the constant and dedicated research work of the company's technical experts. A quality-conscious, eco-friendly and customer-oriented company, KIOCL has been conferred with ISO 9001 certificate for quality, ISO 14001 for environmental balance, OSAS 18001 for occupational health and safety, and ISO 9001 for vigilance services. KIOCL believes that development and environment can coexist. The greenery in and around KIOCL plant is one of the major thrust areas. Greenery is well developed with regular plantations. Water sprinklers have been installed to contain dust. As a socially conscious corporate, KIOCL is actualizing the CSR projects, particularly in the area of education, drinking water, infrastructural needs, community development, women empowerment, public sanitation, and healthcare, etc.
Pellet is going to play a major role in the coming days to improve productivity. As per India's steel policy 2017, India is also going to use at least 25% of pellets in their charge mix by 2030. Today we are expanding our business mostly to port-based plants, especially at Visakhapatnam on the plant of 1.2 million tons. It may come into operation in the next 2 years. One more, we are planning to set up plant at Bokaro, that is integrated under integrated steel plant of SAIL. And if you see other angle, with the expertise, again we are entering into O&M contract, that is of NMDC. We are entering into DI pipes at Mangalore, that is a forward-backward integration of blast furnace. Under backward integration, we are commissioning coke oven and also power plant. Under forward integration, DI pipes. In 2 to 3 years, we are expecting that all the projects, what we are expecting now, it will come into the operations. So we expect after 3 years, KIOCL again will go back to the golden days of Kudurmukh days.
KIOCL, building the nation, pellet by pellet.
Well, thank you, Ankit, but this was rather long. I did not expect such a long corporate video, though it was quite interesting for us, but it was too long. I would like to request Mr. Bhatnagar, you should tell Mr. Saminathan to reduce the corporate videos to 2 to 3 minutes. Otherwise, it becomes too much for everyone to bear. So I think Mr. Saminathan is there at the airport. I don't know. The present chairman, Mr. Saminathan, is supposed to join, but he said he's just checking in at the airport. So once he's through at the airport, maybe he'll join later. In the meantime, we have kept Mr. V.R. Sharma and others, all of us were waiting for a very long time. So Sharma Sahab, let me seek your apology for keeping you waiting for such a long time.
No, my pleasure. I was seeing the presentations. It was very interesting.
Yeah, very interesting, but rather long.
Yeah,
that is
great. No problem. It's okay. It's a great learning because when we see the presentations, then we learn a lot of things.
Yeah,
it's
thank
good.
you,
Very
Sharma.
nice.
Yeah, it's over to you, Mr. V.R. Sharma, our keynote speaker, Vice
Thank
Chairman
you.
of JSPL Advisory Services,
Thank you.
ex-Managing Director of JSPL, and someone who needs no further introduction. Over to you, Sharma Sahab. You are an expert on all the 3 topics we need to discuss today. Iron ore, including iron ore beneficiation, the need for pelletization, application of pellets in not only in our DRI, but also for our blast furnaces. Pellets are being used in the blast furnaces today. So all these issues you can touch upon, and your favorite topic, the role of gasification in DRI. So over to you, Sharma.
Thank you. Thank you very
Sharma.
much. Thank you. Very, very interesting topic in Nirmalaji, challenges and opportunities in iron ore, DRI and pelletization in India. I would say here there are no challenges now. From here onwards is only opportunities. And we have to encash these opportunities. Country is going to reach to 300 million ton steel capacity. So that means opportunities are many. The opportunities are in abundant, and these are the opportunities not only for the steel mill, but for the equipment suppliers, consultants, the technology suppliers, the iron ore beneficiation plant suppliers, the coal gasification suppliers, and of course the pelletization or the pellet plant supplier. So I would like to tell you that once I visited Iran and I found one after another a chain of pelletizing plants, and all these plants ranging from 1.5 million ton to 2.5 million ton. Very good plants. Some of the plants are built by themselves. Some of the plants are based on European technology, and few plants were also supplied by Japan. So this was a wonderful learning. They are today, I would say, largest producer of DRI, and they want to reach to 30 million ton DRI by next 3 to 4 years time, maybe more. So I found there, and once I asked somebody that, what do you see the future of this particular technology and making pellets and then DRI? They said that there are a lot of opportunities in this particular field. And this also I feel that there are opportunities in this particular field. We should all try to encash those opportunities. I also visited once Venezuela, where the series of vertical shaft kilns from Midrex and also from HYL are installed. And they were also, I would say they were the largest producer of gas-based DRI. So 3 countries in the world, India, Iran, and Venezuela. So all these 3 countries are doing extremely well in terms of pelletization and DRI manufacturing. Now, the time has come to go for the beneficiation plants in the country. Today, there's a dearth of beneficiation plant in India. So the true beneficiation plants are required so that we can make a concentrate. Because worldwide now the iron ore transportation is getting an obsolete mode of mineral. So people are focusing on concentrate, iron ore concentrate. So Indian steel mills, Indian miners, Indian mining companies should also focus as to how to supply iron ore concentrate instead of iron ore. So speaking iron ore, it was past. Speaking on iron concentrate, it is present. So similarly, like many times we discuss about coal. So coal, washery or no washery. So time will come very soon, I think in next 5 years, Indian iron ore producers will have to install the beneficiation and concentration plants, where the iron ore concentrate will go to the steel mills. And coal mines also, like Coal India, they will have to put up their own washeries so that only washed coal goes to the power plants or to the steel mills or cement plants or anywhere where people are using coal. This is how we can avoid the dust pollution, and we can also reduce the CO2 emission to a great extent. So the ecological balance will be excellent the moment we have the iron ore concentration plants as well as coal beneficiation in terms of coal washeries. So iron ore concentration is being done by many countries in the world. I visited Australia, I visited Brazil, and I found that people are making concentrates from 100 microns to 600 microns, and then they transport through vessels to wherever the customers they need it for pelletization. And then the customer needs only a very small setup, how to grind 100 micron to 600 microns into 40 micron size, that is 320 mesh, which is required for the as a pelletizing feed, and a small ball mill or a vertical roller mill that can help us in converting 100 to 600 microns into 45 microns, where more than 80% will be 45 microns, and maybe only 10 to 15% will be below and above 45 microns. That is, below means up to 20, and above maybe 60, 70, or 80. So 10 plus 10. So 80 plus 10 minus 10 is like that. So this is what is the phenomena. People need about 2,000, 2,100 blend size for a proper pelletization. So that can be achieved through either vertical roller mills or through the ball mills. But more and more ball mills are there in this particular business. The VRM had just been launched by a few companies, and this will take a little more time. Then the next is a proper filtration machine. Now filtration machines are available, right? Start from 160 ton per hour to 280 ton per hour. Very long and big size of plate type filtration machines, which is giving an edge to the pellet plant owners. They can produce more and more from their plant. So the focus should be, we should develop the concentrate business, that is iron ore concentrate, and also if it is coal, then washed coal. Then the pellet plant in India, it has immense future. I'll urge all of the equipment suppliers. I saw they have an Bocker presentation also here, that they should put up their own factories here now to manufacture all these equipments. Like many companies have already done in Brazil, in Sao Paulo. If you see, most of the Europeans and American companies, they have already installed their manufacturing base. Indian government is working very seriously, I think, for a PLI scheme to the capital goods machinery manufacturers. So this is the right time for the international suppliers to come and to open their manufacturing base in India, because India is having third largest or maybe fourth largest reserves of iron ore, and we are a country where we have a plan to reach to 300 million ton. Each year we are seeing 10 to 15 million ton capacities building YOY, and it will not be too far that we'll reach to 300 million ton per year, which is going to be a big jump from existing 120, 130 million to 300 million ton. And where from the iron ore will come, and the answer is only iron ore beneficiation and pelletization. This is one. And the other is DRI. When it is DRI, we all are working today on the new technologies, how to use hydrogen in DRI manufacturing. We do not have natural gas, blessings in disguise. So had we been owning the natural gas, then people will not think for the hydrogen. We have only two options available today, either to convert coal into gas, that is syngas, or to produce hydrogen through a green energy route. And if we do that, then more and more vertical shaft kilns plants, like the design or equipment supplies by large companies like Midrex and HYL based Tenova and Denali. So these plants will have a great future. But this future will depend upon the cost. So two costs here. One is how to reduce the cost of hydrogen generation from existing $3 to $4 per kg to $1 per kg or below. And the second is how to gasify more and more coal. So if we opt for a gasification route, then it is not a green pellets or green DRI or green steel finally. But if it is hydrogen, then definitely it is a green steel through green DRI. So there is a time. There are opportunities, no challenges. There are opportunities coming on our way to be a front runner player in the world to produce concentrate, to produce pellets, and then produce DRI for steel making. And pellets will have two outlets. One is going to blast furnace directly, and the second is going to the DRI kilns, vertical shaft DRI kilns. There is another big big community we have, and that is DRI through SRN kilns or the rotary kilns, where the coal is used as a source of reductant and energy, of course. And this coal is basically detrimental in terms of CO2 generation overall. So I think the time is come for all of the SRN kilns owners to start thinking on gasification, and finally to have small modules of 400 to 500,000 tons per year, and based on coal gasification, and they can have a very clean process, and the CO2 can also be captured. So that is the future. So I feel there's a great potential, great opportunities in this particular segment. We all will have to come together. Thank you very much, Nirmala. You have arranged a wonderful seminar, wonderful meeting. You have brought people from all over the world on one platform to understand the requirement and also to find out the solutions amongst ourselves. So, ladies and gentlemen, thank you very much for listening to me. Good afternoon to all of you, and let us enjoy this particular session. Thank you very much, Nirmala. Thank you for inviting me. All the best.
Thank you, Salma Saab. Thank you so much. Thanks for sharing your thoughts and also talking about the need for beneficiation and pelletization in a country like ours, where abundant resources are being wasted today because we do not have low-cost pelletization technology and beneficiation technologies available, which we need to promote in this country. And I am sure Dr. Jan Lamke and companies like Haver and Becker Niagara, along with the beneficiation companies, would come forward and make beneficiation and pelletization technologies available at a much lower cost than what we have today. And of course, goes without saying, gasification of using syngas is the right way forward, which till we receive hydrogen at a much lower cost, this is the way forward. So thank you, Salma Saab, once again. And let me just inform you, Mr. Swaminathan, I think will not be able to join because his flight, I think he's taking off the flight. So if I am not mistaken, someone will be joining from Hyderabad, Mr. Naik. Mr. Naik,
sir, good evening to all. First of all, my chairman Swaminathan sir is traveling and he has asked me just now to participate in this webinar. And
he was there till a few minutes ago. He was online, but I think he must have boarded the flight.
Yes, sir. Yes, sir.
So that is why please introduce yourself because I only know that you are Mr. Naik, GM in KIOCL. So please do the introduction and then you can share the presentation of CMD. Mr. Swaminathan, I think he has already posted the presentation in the group. So you have to just share the screen, that's all. So over to you, Mr. Naik. Please introduce.
Good evening to all, gentlemen. I am Ajay Naik, in charge commercial, KIOCL Bangalore. I am basically a mining engineer, BTech mining from REC Surathkal. At presently, I am heading the commercial department in KIOCL, sir. And at the outset, I would like to thank Steel and Metallurgy for giving this an opportunity for KIOCL. Of course, I am representing my chairman, Mr. T. Swaminathan, sir. And I will be telling in brief about iron ore scenario and pelletization and DRI. Presentation visible? Yeah, presentation. Share it.
Yeah, you can just share it. The presentation is already posted in the group, but you can just share it on the screen. Yeah.
To scroll down.
Yeah,
in the meantime, there are two questions I'm seeing. One is somebody has asked whether EF is okay for melting DRI, which is produced through iron ore pellets and mixed with hot metal from blast furnace. Yes, please. It is possible, and people are doing it. And the other question was asked: can we charge coal-based pellets DRI in EF? Yes, we can. We can charge even up to 100%. There is no problem. And it is, of course, economic. The question is it economically viable to make? Is it economic viable to make construction grade steel? Yes, it is economically viable to produce construction grade steel. Rather, I would say it is much better because the nitrogen content in DRI produced through the coal-based route is higher side. So for flat products, this creates problem. The nitrogen contents will come about 70 to 80 ppm, whereas in construction steel like rebars or angle channels or anything, this does not create any problem. So sorry, I jumped in between just to answer these two questions. Thank you very much.
Thank you, Sarma Sahab. In fact, the knowledge base from Mr. Vidyaratan Sharma is something which no one can replace on this platform. So really grateful to you, sir, for answering the question. And over to you next, Mr. Nayak. Please go ahead. You can start with your presentation.
Mr. Nayak, over to you. Thank you very much.
Sir, I will be touching upon in brief all these things. Iron ore scenario, as all of us know very well, India is blessed with high reserves of iron ores, and we have got around 33.2 billion tons of iron ore resources. 22.48 is of hematite and 10.78 billion ton of magnetite deposits. But iron ore production is in India is also year on year it is increasing and picking up pace and in India. Basically here commercial mining is taking place in hematite only because of so many issues. Magnetite deposits in India are not being exploited, mainly because they are in the eco-fragile zone of Western Ghats, and magnetite mining is at present it is not taking place in India. So as far as opportunities in India at present for iron ore is concerned, and is NSP, we are all aware, by 2030, Government of India planning to produce 300 million tons of crude steel. This is a greater opportunity for iron ore mining in India than Government of India policies, if you take, allowing 100% FDI in the steel industry, Make in India initiative, and reduction in the custom duty in plant machineries, and infrastructure project in India, spending on infrastructure project in India is, and amendment to MMDR Act regarding exploration. These are all the things which at present are adding iron ore mining, and there is a great scope for iron ore mining in India. So in order to maintain this raw material security, there are many steps need to be taken, and exploration to new deposits, converting remaining resources of hematite into reserves, and low grade, mining up low grade, that is beneficiation, we can say, proper evaluation of magnetite resources which stand as 10.78 million ton, and exploration to greater depth. These are all required at present, but it comes with the challenges of this exploitation of these resources. There is added challenges like challenges of environmental issues and mechanization, mining at greater depth, and in eco-sensitive zone, that underground mining is also has to be concentrated in India. Mining at underground for bulk resources is not taking place, and there is a lot of scope for advancement when drilling and blasting, because blasting is an ever-evolving technology that we need to concentrate on those issues to tackle these issues, sir. Then pelletization, nowadays it is a very talked about topic, because we are doing commercial mining in hematite only. Hematite reserves are getting depleted day by day. Magnetite, we are not in a position, and again, the low-grade iron ore which has been dumped at the pit head, it is causing environmental problems. All these things, and the Government of India initiated the carbon zero carbon net carbon reduction. All these things are it gives lot of opportunity for pelletization. Pellets are, as you know, pellets are prepared over sinters or iron ore mines because of so many issues there. Their porosity, their reducibility, then high CCS and zero emissions, and all these things are giving good opportunity in India for going for pelletization, sir. And if you see in India pelletization, the installed capacity of pelletization in India is increasing year on year, whereas the capacity utilization is not taking place to that extent. Main reason is that in India, whatever pellets are being produced, that much of pellets are not being consumed in India, and whatever the DRI installed capacity is there, for that also we have got surplus capacity of pellets being produced in India. And the next option is for captive producer like KOSL to export the pellets. But as you know, export market is highly volatile because of so many issues, like our cost of production is very high. We are not able to compete with global players with regard to price competitiveness is concerned. So because of that reason, we are not, India is not in a position to capitalize on its existing pellet capacity also. And out of 127 million ton installed capacity, around 76 million ton per annum is for captive use and rest is for merchant user. So there is a surplus pellet installed capacity for pellets in India. These are all the relative advantage of pellets. As we have already told, it's a zero carbon imprint and it is the best suitable for DRI plants. But what is the way in India? What we need to do is that still in India that usage of pellets in blast furnaces that is compared to Europe or steel mills, it is not to that extent. We have to increase the burden ratio, the use of pellets in steel industry, that is BF grade pellets, to maybe not even if 100% also, we can increase the usage of pellet. This gives an opportunity for the captive manufacturers in India, because we have got a huge capacity of pellet production for it will aid the industry in India, sir. Then this is all again the pellets in DRI, 23 increase in production, then reduction in specific consumption, longer campaign life, and no need to crushing and no handling losses and all. These are all the advantages. It's very common and general advantages of pellets in India. Pellets usage, pellets compared to even iron ore sinters and lumps, sir. Next is the DRI industry, sir. We have almost roughly around 51.2 million capacity of installed capacity of DRI in India. But as I said earlier, whatever pellets we produce is much more than the requirement of pellets in India. So for DRI units also, pellet production is quite sufficient in India. We do not have any shortage of pellets in India, sir. So this is the development of DRI industry in India, sir. In a nutshell, it is self-explanatory. It is mainly used for substitute for steel and approved, sir. DRI doesn't require coking coal imported in huge quantities. So this, because India is having shortage of coal, this is an advantage of DRI route of DR route of steel production, sir. And direct reduction emerged as a quality supplement in place of scrap and steel making. So there is a lot of scope for DRI industry. Demand for DRI is to increase to 80 million ton per annum with the installed capacity of 114 million ton annum, in which 30% through gas-based route as per National Steel Policy 2017, sir. So as I said, sir, limited availability of coking coal in India is the main, it is a plus point for us. We can always go for DRI, BF route of steel production. But again, the main advantage of DRI is having known is chemically with low tramp elements, which helps to make EAF is also usage of reduced friction. But the way looking forward with respect to DRI industry is concerned, shortage of scrap always drive the demand for DRI. However, merchant pellet producers must think of forward integration for long-term sustainability and use of more pellets for improved productivity and CO2 emission in DRI industry, sir. Thank you, sir.
Thank you, Mr. Nair, for highlighting the need for DRI in this country. In fact, just the other day, we were discussing, and I sent across a message to Mr. Abhijit Narendra, Joint Secretary, Ministry of Steel, about the need for Government of India's support. And Ministry of Steel must come forward to support the DRI industry and the pellet industry to promote the use of pellets in our blast furnaces, in our so that the excess capacity of pellet production is gainfully utilized. And of course, the margins of pellet industry is also something I'm sure Mr. Bhatnagar will talk about today, the challenges that the pellet industry faces today. And there is an urgent need for support from the government to promote the use of pellets in all our units, including DRI and in blast furnaces. So with that, I thank Mr. Nair for once again highlighting these issues in a very way. And my special thanks also to Mr. Swaminathan, the Chairman and Managing Director of KOCL, who was there with us for quite some time, but unfortunately he could not join for the presentation because he had the flight to take. So thank you, Mr. Naik, and please convey my sincere thanks to Mr. Swaminathan for highlighting the issues which are so very important today.
Thank you, sir. Thank you once again.
Yeah, I would also like to express my sincere thanks to Ministry of Steel, who are actually taking this issue up, and Mr. Kashiva, my friend who is heading the Sponge Iron Manufacturers Association, is also discussing this issue regularly. He was originally in the Ministry of Steel, so it is easier for him with his relationship with everyone in Udyog Bhavan to take the issues up. And I would also like to mention that today Mr. Anil Kumar Chaudhary, the ex-chairman of SAIL and who is now the group CEO of SR Minerals and Metals Vertical, he had an urgency today because his brother-in-law had a sudden heart attack and admitted to hospital. So he had to go to the hospital, and as such, he could not join us. But then I'm sure Mr. Chaudhary will be there with us in our future endeavors as well. So the next speaker is again Mr. Someone who needs no introduction because he's been there with Danelli for more than 22 decades. And my good friend, Mr. Paolone, has been kind enough to request Mr. Massimiliano Zampa to make a presentation on Danelli Centro Metallics on their initiatives towards DRI and agglomeration technologies. So over to you, Mr. Massimiliano Zampa, Vice President, Engineering and Process Technology, Danelli Centro Metallics from Butrio in Italy. So buongiorno once again, Mr. Massimiliano, and over to you.
Yes, good morning, everybody. Thank you very much for your warm welcome. Okay, and thank you also to attend to this webinar. That it was a very, interesting argument, because from the ore at the end to the metallic. What I would like just to present to you today is a small overview of Danelli about this, not only to Danelli, also to some new rumors that is coming from the world. In particular, okay, I will just start to pass through all the three arguments, iron ore, pelletizing, and DRI, and try to make some conclusion. Some people before me already started correctly to look that India at the end is one of the biggest reserve of iron ore in the world. Here we try to summarize which are the biggest one, okay, in the world, and also which are the main producers of iron ore. And also in this case, India is one of the biggest producer of iron ore in the world, okay, compared to Brazil and Australia. And here we have the 10 biggest company, iron ore producer in the world, like a company. In this case, okay, in India, we have NNDC, that some people are here in this webinar, okay. The data is coming from last year, 2022, with a ranking of 2020. But also, the movement that we have of the iron ore around the world. So we can clearly see that different people are mainly importers of iron ore, and others are mainly user, and like India, according to our information or the information that are available, is mainly using internally the iron ore that is produced. But as already Mr. Sharma already correctly highlight, iron ore is not okay. It's better to start to speak about concentration, because otherwise we can just move some we can say not good materials from one side to the other, and for this reason the best solution is to install a beneficiation plant. I would like just to show to you one of the plant that we built in Middle East, okay, to produce 2.6. In reality, now is producing more than 3 million tons per year of iron ore. We make this plant with two main purposes. One purpose is, of course, to increase the percent of iron in the filter cake, because we start from something like 48% of iron, and we reach at the end in the filter cake the percent of 68% of iron ore. In addition to that, one of the purpose of the plant was also to eliminate and to reduce the impurities, in particular the sulfur and the phosphate. That is, as you know, is not some impurities that make the steel not in good quality. So at the end, we design all the process and all the equipment starting from the mine up to the last phase, that was the filter cake, with the size of 48 degrees. This filter cake can be later used to produce a DRI grade pellet. All the process are made in wet phase in order to have a low environment impact. Means that all the dust are almost eliminated because we are moving slowly. We had, now we can go through the building. We have 3 different stage of grinding, starting from agi mill, ball mill, tower mill, and after that we make dewatering using filter press. Let me little bit accelerate. Yeah, so we have a primary grinding, with the 700 tons per hour, a ball mill that you can see on the behind, of course, in every stage we have some filtration or separation, or by screens or by hydrocyclones, depend of the size of the filter cake. In this case, the separation was made by magnetic separator due to the kind of milliner. We also design all the automation system. So we make all the level 1 and level 2 of the plant up to the last stage that, as I mentioned before, was 38 microns. The result was the filtering by the filter press to obtain the filter cake to be used to produce pellet. Here we can see the filter cake that are discharging and moving to the stockyard. So in principle, we start from iron ore with only 47% of Fe. We arrive to a concentrate that starts with 68% of Fe, and after that, using chemical flotation, we remove sulfur and phosphor. Just to be very clear, in order to fix the correct process before to start, is necessary to make different laboratory tests in order to be sure to fix the process in the right way and to be sure to arrive to the final target. Of course, as already mentioned also from other people, after the to make the good fines, we need in some way to agglomerate these fines for any use that we will need in the next stage, blast furnace or DRI plant. What I would like just to show today is something that was quite curious for me, that is ongoing by Vale, where they are trying and they are declared that they are succeed to make agglomeration without pellet, but without pellet plant, sorry, but using cold briquetting. All this material is coming from Vale. I just take from their side and take the information of a presentation that they did in September during the Energiron meeting that we had here in Butrio. Okay, so they declare that with this briquetter, they can jump out completely of the sintering plant and also from the pelletizing plant. They are just make this briquetted with a special binder, okay, and they're just drying the briquetted up to 200 degrees instead to firing to 1300 degrees. So you can imagine also the saving in CO emissions if this solution can work. They already did some tests. Okay, they already tested in different blast furnace. So they tested in 6 different blast furnace for long period. Seems with good results. And also, they are also tested with basket test in some DRI plant, in particular also in some Energiron plant. And now we are in contact with one of our clients to, in some way, to participate to the next stage of basket test in their plant to understand the behavior of this briquette. From the first data, seems that this briquette can maintain a good shape, so they are not disintegrate during the reduction, and also they are obtain a very good metallization up to above 94-95% of metallization. And according to the information that Vale shared with us, during this year, in the last part of second part of 2023, they should put in operation an industrial plant in Brazil, in Minas Gerais, converting old pelletizing plant to produce 6 million tons per year of this briquette to sell in the market for blast furnace. And they intend to install a new plant of 0.75 up to 1.5 million tons per year, new plant to produce this briquetting. If you know, there are also signed a lot of MOU around the world for sharing this technology, in particular in Middle East. Now, after obtaining this briquette, or better to have this iron ore, we move to the final stage, that is to obtain the metallic, okay, and in particular using the DRI technology to have a good metallic to share, to feed in the electrical furnace. In this short video, we can resume which is the final use of the DRI to produce, of course, liquid steel, good quality. If we have a starting point, of course, a good iron ore with low impurities. And here you can see some part or some of our plant that we are built around the world using the Energiron process, Energiron 3 with the reformer, or Energiron zero reformer plant. Okay, in all this plant, of course, we are starting from iron ore pellet to obtain DRI. We can make different solutions, DRI feed directly the electrical furnace or produce cold DRI. Last but not least, we have also the part related to the hydrogen, because if you look the scheme of the Energiron process, one of the big advantages that we have is that according to our process scheme, we are able to feed the process scheme with different sources of gas. We can use natural gas, reformed gas, but also coke oven gas. Now is already start up a plant in China using coke oven gas, and we are under construction at a second one. But we are able also to use, that was mentioned before, also sim gas, so gas coming from coal gasifier, or in the future, if correctly Mr. Sharma mentioned, when the cost will be sustainable, we can use hydrogen. The main component of our process is a process gas heater to heat up the gas. We have a reactor where we are able to make all the reforming reaction and reduction reaction. A compressor, because respect to the competitors, we are working mainly in pressure. Let me a second this, okay. We have a CO2 absorber plant, so we have already make a carbon capture in our process, and we are able to produce different kind of product called DRI, HBI, or feed directly the electrical furnace. Just one note, as you can see, our process gas is already rich of hydrogen. We have already up to 70, 65, 75% of hydrogen already present in our process scheme. Here, I would like just to highlight three main figures that is the advantage, in our opinion, of the Energiron. That is, of course, the low CO emissions compared to the root blast furnace BOF, okay, low NOx emissions, and the high metallization that we can reach, and the fact that, according to the before scheme, we are in principle already ready for the 100% hydrogen. To make some conclusions about this short overview, as we already mentioned, there is iron ore is different case to case, but the best way is to make to treat this iron ore in order to increase the Fe content and avoid to move waste part around the world, and also in order to avoid to move this waste part in the downstream process. Some new technologies appearing in the agglomeration scenario. This is better to maintain monitoring. DRI, as everybody knows around this table, of course, is the green way to obtain metallic able to feed the steel making plants, and it is an opportunity for the future. And this is something that is also well known around the world. A lot of players, steel making players, European, but not only European, are already decided to move from the old integrated plant to the solution DRI and EAF. Here I put just some of the last order that we acquired for Salzgitter, for ArcelorMittal, and also the develop that we did together with Hybrid in 100% of hydrogen. Thank you very much. I hope that this small presentation gives to us some good ideas to think about.
Yes, Mr. Zampa. First of all, let me thank you. Grazie.
Thank you to you.
For an excellent presentation where you covered the entire topic of decarbonization also as a part of your presentation, which is the most discussed topic today. How could we reduce our carbon footprint when, as Mr. V.R. Sharma also mentioned, when the cost of hydrogen is still very high? We have to bring it down to at least $1 per kg or below that.
Correct.
And we reach that figure. I think, as you also mentioned, syngas is a very good solution. So we can use ways and means to reduce our fossil fuel dependence, or at least the carbon footprint, through the resources that we have today. Thank you so much, Mr. Zampa.
Thank you.
And next year, I'm sure I'm going to see you in Italy in Butrio when you have the Danelli Innovation Summit next year. Danelli Innovation Meeting next year, perhaps in May or June. I don't know when you will have the DIM, but I will be there for sure with you to enjoy some good grappa.
Well, you will be welcome, and will be my pleasure to spend with you and drink, of course, one glass of grappa together.
Yeah, thank you so much once again. And please stay connected. Please don't leave, because I want you to hear the presentation of Mr. B. Sahu, who is the Executive Director, Production and Coordination at NMDC. which
Of
is
course.
again the largest iron ore producer in this country.
Yes.
So over to you, Mr. B.D. Sahu. You can start sharing the presentation. Yes. Mr. Sahu, you just need to make it full screen, that's all. Just put it on the full screen mode. That is excellent. That is fine. Yeah, you can go ahead. You are muted, Mr. Sahu. You have to unmute yourself. You are muted. Please unmute.
Yeah. Am I audible, sir?
Yes, you are very much audible, loud and clear.
Yeah.
No problem at all. Please
Good
go ahead.
afternoon, sir. Good afternoon to all, and good morning to all others who are out of India. And this is small presentation, mainly focusing on the opportunities and challenges of iron ore as well as pellets. Next slide. Yeah. So, as all of you know, India is endowed with a large reserves of iron ore. With respect to magnetite resources, there are 10.79 billion tons of total resources, out of which hardly around 1% we have proved as a reserve, and very less quantity we are mining. And in respect of hematite resources, presently we are out of the total resources of 22.49 billion tons, we have proved 24% as reserve, and still a huge gap is there for making it detailed exploratory drill for proving the resource to reserves. Then the total untouched resource is still 76%. With respect to national steel policy, as all of you know, India is paving the way for increasing steel capacity, which was 125 million ton in the year 2070. That is poised to increase 300 million ton capacity by FY30. And in respect of steel production also, we have we are in progressive path to increase the production level of 97 million ton from FY30 to 255 million ton by FY30. And iron ore production is also increasing gradually. And the iron ore production, it is poised to be increased up to roughly around 450 million tons by FY30 from the present level of 256 million ton, which is the last year production in India. And as all of my predecessors, they mentioned that India and through whole world is now poising, and they're aiming for from the BF route to EAIF route for energy conservation as well as minimizing the carbon emission. And global iron ore production, all of you know that last year production was roughly, iron ore production was 2,500 total 2,500 million ton. And similarly, the steel production was around 1878 million ton last year. And this slide shows the country-wise production. And moving to the next slide, the main, as my previous speakers, he has also mentioned the main players in iron ore productions are Rio Tinto, FMG, BHP Billiton, Anglo-American, Vale, and some others. So these are the scenario of major players worldwide. And coming to Indian steel production, last year we could do 126 million ton of steel production. And rank-wise, JSW has produced around 20.2 million ton, Tata Steel 19.8 million ton, Steel Authority 18.2, JSPL 7.5, and AMNS ArcelorMittal Nippon Steel 6.7, RNL 4.1, and others 49.5, totaling to 126 million ton steel last year production. And in respect of iron ore production, last year we have produced around 255 million tons of iron ore in India. And number one is among the top players, top 10 players, number one is NMDC, followed by NMDC 41.2 million ton, followed by Tata Steel 36.3, SAIL 34, Orissa Mining Corporation 29.7, JSW 28, Rungta and Sons 13.4, ArcelorMittal 9, JSPL 8.5, Vedanta 5.3, ESL Steel 4, and others 45.7, totaling to 255 million ton of iron ore. That is last year production. And I will just touch upon how what is the plan of NMDC in near future. Presently, as I told you, we are producing around 42 million tons of iron ore, which is roughly around 18% of the total country's production. And we are aiming to produce 100 million ton. And in fact, we are aiming to produce 67 million ton by 2026. 67 million ton by 2026 and 100 million ton by FY30. So for this purpose, all the necessary preparatory arrangements, including the infrastructure development, installation of new plants, purchasing of new equipments, everything has been planned, and we are in process of implementing all the planned activities. And we are also at par, our progress is at par with respect to the target. So this is the vision plan of NMDC. From where present level of 42 million ton, we are aiming for 30 million ton by FY30. And coming to the major topic of this today's session, that is challenges. What are the challenges? In Chhattisgarh, we face a major challenge with respect to local unrest and Maoist issue. Though a lot of steps have been taken by government of Chhattisgarh and government of India, still improvement is required. And I will tell you that one very good deposit having iron ore Fe content of more than 67% and with reserve of around roughly 400 million ton, it is still untapped. Though we have got all clearances, still untapped. We are not able to do mining because of the local issues. So that type of issues are there. These are the challenge we have to resolve. Similarly, environment clearance for the new projects are taking too much time. Though on paper or as per the statutory norms, they should clear within 4 months, that is 120 days. But we, in real sense, it is taking more than 2 years for getting environment clearance. Similarly, in Karnataka, the Central Empowered Committee of Honorable Supreme Court, they have capped the production capacity in Karnataka to 50 million ton. So each mine, though they are capable to produce more, but capacity of production and level of production has been capped by Honorable Supreme Court of India. And similarly, in Karnataka, we face in the sense the whole mining industry, they face forest department has stopped the dispatch of iron ore in different mines of Karnataka during night hour, that is 6 p.m. to 6 a.m., stating that jungle animals or forest animals, they may get disturbed. So whereas in other state of India except Karnataka, this is not the issue. So some parity is required. And similarly, for getting forest clearance, for diversion of forest land, for opening the new mines or setting up new infrastructures, we are facing a lot of problem in respect of forest clearance, starting from the DCF or district level to up to New Delhi. And though we should, as per paper, on paper it is mentioned we should get within 4 to 6 months, but actually in real sense it is taking more than 3 years. And in some cases, people are some company they have faced for obtaining forest clearance more than 6 years also. So these are the problems. Then enhancing EC capacity of the existing mine. Recently, Ministry of Environment and Forest, they have circulated up to 20% we can go without getting additional environment clearance. But while approving, they are taking a lot of time. Similarly, another challenge is additional area requirement for waste dumping in the existing mines. This is applicable throughout India, not only for iron ore mine, for all other mines. In fact, many of the Indian mines are more than 50 years old, and at that point of time when they got the new leases, they have reserved very less area. Without forcing that the mine will sustain for more than 60-70 years. So over a period of time, that depth of operation has increased. The more we go deeper by deeper for obtaining for excavating the ore, laterally we have to expand. So while expanding laterally, we need more area. So now so many mines are facing problem because laterally we cannot expand. After getting certain depth, there is a expansion of lateral expansion in all 4 directions is a must. If we don't get additional area at the top of the pit or top of the mine, then the chances of expanding the production level and as well as safety, ensuring the safety, it becomes very difficult. So additional area requirement for waste dumping is a critical top subject now, and a lot of thought has to be given for this respect. Then while allocating the new mines, especially for government companies, though provision is there under 1782A, but in real sense, very few government companies they are getting new mines through auction, through direct reservation route, and through auction it is not possible to bid more than 100% or 85-90%. And similarly, auctioning of mines and transfer of the statutory clearances to the new bidders. Government of India has already decided that there should be seamless transfer of all the statutory clearances, which was being held by the old mine or the or the mine belonging to that old mine owner. All the statutory clearances while transferring to the new lessee, it is taking a lot of time. They have given 2 years. So within the 2-year time, in the transferring of the new leases, transferring of the old documents in the name of new lessee, it is taking more than 2 years, and in some cases, it has taken more than 5 years also. So this is the status. Then there is high rate of rarity. In my next slide, I will show you the rarity level of India as compared to other countries. And there is also high rate of compensatory afforestation charges in India, especially in Karnataka state. They have increased from 3 lakh, 3.5 lakh to 18.5 lakh within a span of 5 years in Karnataka, which is not the case in other states. And similarly, in pelletization respect, making pellet out of these slimes or microfines, our Sharma Sahib, he has also told a lot of things about this. We are also planning for the same, and we have set up a plant for converting these slimes into pellets that is in operation. But disposal of the tailings after making pelletization. So say for example, 100 ton I am feeding to pellet plant. I am getting rejects to the tune of roughly around say around 60 tons. So that 60 ton, disposing the 60 ton in other area, other than the mines area and other than the pellet plant area, we need some particular area where the tailings to be disposed of. So that has become a challenge now, disposing of the tailings after beneficiation of the ore in the pelletation for pelletation purpose. So this is the threat now. Without getting additional land, we are facing difficult. Not only NMDC, all the mine owner, they are facing difficulty in India for dumping the tailings, which needs attention. Next, this is table. It is showing the percentage of royalty, which is presently or directly royalty. We are giving 15% against 2 to 7% in all other developed countries like Australia, Brazil, Canada, and USA. All these countries, they are paying very less royalty. In India, we are paying high rate of royalty. So these are the things, challenges and opportunities in respect of iron ore and pelletization in India. Thank you all. Thank you, the organizers, for giving me this opportunity. And thanks. Thank you all.
Thank you so much, Mr. Sahu. Sahu Sahab, thank you from the core of my heart. Let me express my sincere thanks to you for highlighting the issues of NMDC also, because expansion of iron ore is a must if we are to reach 300 million tons of production. And if I just, even if I put the figure around 250 or 60 million tons and multiply by 1.6, so we will need close to 500 million tons of iron ore by the year 2030. And then we look beyond to 2047, when we are targeting 500 million tons of production. Obviously, 500 into 1.6 becomes almost 800 million tons. So that is the need for expansion in production of iron ore in this country. And NMDC being the flag bearer, the others being OMC, the private mine owners, and everyone should look at a strategy to get the clearances faster and smoother, both from the state as well as from the central government, from Government of India as well as from the state governments. A single window clearance is what we need as a need of the hour. At the same time, tailings management, as you rightly mentioned, management of tailings, which I'm sure UNRIN will also have solutions ahead, how to effectively handle our tailings, which even in steel plants is a big challenge today. So with that, my special thanks to you once again, Sahu Sahab, and please stay connected.
Thank you very much.
लेकिन आप Sahu Sahab आप जाइएगा नहीं, please stay with us, because
I am here only. I am here. I am listening all the presentation.
Thank you, sir. Thank you. So now the senior most person I always keep referring to, Bhatnagar Sahab, Mr. Deepak Bhatnagar, who has spent years in this industry, also with SAIL, and has been a major contributor to all our webinars in the past also. And his smiling face is what I miss most when I'm not in there, when Bhatnagar sir is not there with us. So his smile always keeps us going. A wonderful human being and a person whom I would like to spend time with. And over to you, Bhatnagar Sahab, followed by Mr. Jan Lampe, who is the Technology Unit Pelletization Manager for Haver and Becker Niagara. So back to back, Mr. Bhatnagar, followed by Mr. Jan Lamke. Bhatnagar Sahab, the floor is all yours. Mr. Bhatnagar is the Secretary General of Pellet Manufacturers Association of India. Over to you, Bhatnagar Sahab. Bhatnagar Sahab, you are muted. Unmute कर लीजिए. आप unmute कर लीजिए. और रेड बटन को दबा दीजिए, you will be unmuted. और रेड माइक का जो बटन है ना, on your left.
आ गया. Okay, thank you. Thank you, Nirmalya ji. And I want to correct you first. I am not the senior most guy around. I may be the eldest guy in age. Senior most, you have stalwarts like Mr. V.R. Sharma. He is almost like a chairman level, vice chairman. And I would like to be start with a very humble apology, because I find that in your speakers list, you have people like stalwarts in pellet industry. Like I see the name of Mr. Indrajit Paul of Tata Steel. I see the name of Mr. P.R. Prasad from BRPL. I just listened to the presentation of Mr. Nayak on behalf of Swaminathan, then Mr. Sahu, and of course, many others. So I am really humbled that, whatever I will be saying is, in metallurgy, when I was studying metallurgy in Roorkee, there was a saying called carrying coal to Newcastle. I wonder if many people have heard about this phrase. Newcastle is a very famous coal mines in Britain. So when we studied iron making in Roorkee IIT, I still feel God has been so kind to India. Bashforth is the book on iron making, which says the iron ore Fe content in England is around 52%. And when I started working in Bhilai Steel Plant in the year 1972, I went to Rajhara mines. I was surprised to see 63% Fe. So we should thank God. This is the good news that we are, what our Modi ji says, we are Atmanirbhar, totally Atmanirbhar in iron ore. So with these words, I will start my presentation with the covering slide. If you see, is two pictures. These two pictures symbolize my entire presentation. The top picture is nothing but waste of iron ore. It is like 120 million tons of iron ore lying in dumps all over the mines in India. And you know why it is lying? Because it is lying this big, the top picture is nothing but dumps. So this is waste. I call it waste to wealth. If you see the top picture is totally waste. In the last 60 years of steel making in India, this has been dumped in iron ore mines all over the country. If you ever go to any iron ore mine or any steel plant, I recently visited my own plant, Bhilai, went to Rajhara, millions of tons of iron ore is lying there. And the bottom picture shows pellets. So these two slides summarize my entire presentation, and two words symbolize my presentation. The two words are value addition. From the top picture to the bottom picture, what we do in Pellet Manufacturers Association on all the pellet plants is value addition. Next. Now, this is nothing but the thing which I just mentioned, waste to wealth. This has been received a lot of support from the government. Now there is a phrase called circular economy. Circular economy means right from iron ore to scrap to finished steel, you recycle everything and use, reduce, reuse. Now, I mentioned that India is so lucky. God has been very kind to us. The good news is we are Atmanirbhar in iron ore, but we are not. The bad news. The bad news is the bulk of our iron ore is hematite. Something like 5.4 billion tons of iron ore is hematite, which has just 41% is below 62% Fe. This is very difficult. The other problem is that 68% of the iron ore fines is in the form of fines. Fines means minus 10 millimeter. Now, minus 10 millimeter, those of my friends sitting here who are metallurgical engineers, you just cannot charge minus 10 millimeter into a blast furnace. You know why? Because the upward flow of carbon monoxide will choke the whole blast furnace. So what do? The only thing is this 70% iron ore, the fines, you have to convert it into some kind of agglomerate. What does agglomerate mean? Some kind of putting together all these fines. So there are only two technologies in India and the world. One is called sintering, one is called pelletisation. Next. Now, this is a kind of a genesis of pellet plants, pelletisation in India. I won't read all that. I'm just reading the highlights. The highlights is that we have the mineralogy, if you see. Iron ore mineralogy contains hematite. Mostly it is hematite. Now, hematite is a very friable. This friable word means in Hindi, very quickly it becomes chura. If you throw a piece of hematite down on the earth, it becomes chura. And the tragedy of Indian iron ore is that this chura wala thing is increasing. Right now, it is around 68% fines to 32% lumps. So the only thing is you have to agglomerate. The other thing you can do is that you can, the mineralogy you study the iron ore ki, उसमें goethite is very high. Now, goethite is very fragile and it generates ultrafines. So this is one issue which we need to solve, and pellet plant is the only answer as of today. Next. Now, this is a slide which our friend from Mines and NMDC has already told you. I would only urge you to see this line. Out of 5.4 billion tons of hematite, 41% is low grade, which means it is below 62%. Next. Now, what is the pellet industry in India? You'll be surprised, India, we have the 5th largest pellet industry in India. The first pellet plant was made in the 1960s. It's a place called Mandori in Goa. Still today, that plant is working. And recently, they have become our members of Pellet Manufacturers Association of India. The second plant, you have already heard Mr. Nayak and Mr. Saminathan. It was 8.7 in 1987. KIOCL was built up with a pellet plant, and it is still one of the finest pellet plants in the country. Third was Tata Steel. Our friend Indrajit Paul is sitting here. He will tell you that was the 3rd largest and still one of the most efficient pellet plants in the country. We are self-sufficient. As the previous speaker also mentioned, there is absolutely no shortage. Something which I need to keep on highlighting, blowing our trumpet, there is no shortage of pellets. Contrary to many newspaper reports, many people who have a different lobby, I will have to say, that they say there is a shortage of pellets. They say pellets should not be exported because there is a shortage. I'm really surprised. If you go through the statistics, we have around 133 million tons per annum capacity, but we are only using around 80 million tons. So this is our biggest challenge. Actually, Mr. V.R. Sharma says, there is no challenge now. There are only opportunities. So I beg to differ. The biggest challenge is how to convert this 120 million tons of iron ore fines which are lying on mines pitheads to convert it into pellets. Now, again, I said out of 133 million tons, captive and merchant. Captive means, just to explain in user-friendly language, I find that around, thanks to Mr. Nirmalya, around 90 participants are hearing us, listening to us. So I can tell what our captive means. The plants which manufacture pellets, but they use like plants like JSPL. They produce Tata Steel. They produce their pellet and use it. The other is merchant pellet plant. We have Mr. PR Prasad from PRPL. They are a merchant pellet plant. What does merchant means? They make pellets and they either sell it to domestic producers, but domestic बहुत difficult है. Most of them are export oriented. They don't have captive mines and they are dependent on merchant mines for iron ore. One good thing, both the governments, the present UPA and the earlier NDA government, have kept duty-free exports. I'm just quickly selling the how much money is generated by the pellet industry in India. You have just seen it's around 7,800 crores, right, just from royalty. Of course, we agree with the previous speaker of NMDC that we must reduce this royalty to maximum 5 to 6%. I'll come to that. To it be at par with the level playing field of the world. GST collection, as you see, over 12,000 crores. Foreign exchange earned last year was very less, $800 million. But in the previous year, it was around $1,300 million. Next. Now, this is one question for the layman. Why pellets? Why are we talking of pellets? The only answer is pellets is a kind of a necessary thing because there is high quality iron ore is depleting. Like I mentioned to you in 1972, when I joined Bhilai Steel Plant, there was a huge amount of iron ore lumps available. And all those lumps were 62, 63% Fe. Now, slowly, lumps are going down. As I mentioned, around 30% of the iron ore is lumps or less than that. and mostly it is fines. So the fines and ultra fines, fines means minus 110 millimeter means 100 micron, and less than 100 micron ultra fines has to be used in some form, and they will slowly form a higher share of iron ore sale. What my friend Mr. Sahu mentioned, that slowly this iron ore of undersize will increase. So what are we doing? Iron and steel producers are looking into the possibility of increasing the portion of pellets. Right now, we are looking after a very important study group made by Ministry of Steel on material efficiency, headed by an ex-secretary Mines. And the result is coming that we need to increase the pellets at least up to 50%, which will improve the productivity and reduce gaseous and solid emissions. Now, this is a very important slide. What is the main benefit of using pellet versus sinter? As you can see, the sinter, the SOx, sulfur trioxide, nitrous oxide, carbon monoxide, carbon dioxide, particulate matter is so high in case of sintering as compared to pelletization. The first line says 85% reduction in emission rate of CO2, 90% SOx, and use of pellets will have a definite advantage. Number two advantage is pellets have a very high cold crushing strength. Now, when people who are metallurgists, they know in a blast furnace, if you charge sinter at the top, while it comes to the Bosch region, it becomes like fines. So what happens is pellets have a very strong cold crushing strength, which is called CCS. It's around 200 kg. Other way, tumbler index is around 86. So these are all figures which are very important for. Now, these are the three somebody mentioned about sinter versus pellet versus cold briquettes. Pellets have an aesthetic advantage. It looks good, of course. Aesthetic means it is round. But the biggest advantage of being round is that when you charge pellets in the blast furnace, the upward flow of gases, the blast furnace is all about downward flow of material, upward flow of gases. So pellets have an advantage because they are round and the gases can easily pass through them. It improves the productivity of blast furnace and it reduces slag generation. Slag generation, you know, in India, we are not blessed with good iron ore in that sense. We have high alumina, we have high silica to the range of 3 to 4%. What do? We charge more limestone. When you charge more limestone, it is like flux. What happens to the flux? The slag volume increases. And the last advantage is mineral conservation. 70% of iron ore fines is above 60%. So pellet industry uses these iron ore fines to make pellets. So mineral conservation is a very big advantage of use of pellets. And of course, mines, the scientific development of mines is helped by use of more pellets. Now you just see, this has been highlighted by our friend from KIOCL. It's a huge, in the last 13 years, from financial year 10 to now 23, almost like 400 times the pellet increase has been there. It's from 26 million tons to 134 million tons. And 62% of this, if you see the right side bar chart, is 62% is from the eastern region. If you see Odisha, West Bengal, Chhattisgarh, but the right side, 51 million ton, is from the southern and western states. Next. Now, this is one of the hottest topics in the country right now. I won't go into detail, but Mr. Sharma raised this and everybody has raised this. And decarbonization is a very, very difficult topic. We need to do something about it. Ultimately, it means how do we reduce the carbon footprint? So decarbonization in the Indian entire steel industry is a very important step. And our Prime Minister has promised in the COP26 that by 2070, we will have zero carbon. So this means the footprint and the use of pellets, that's the advantage of pellets that it reduces the emission rate of carbon dioxide, which I mentioned earlier also, by 85%, sulfur dioxide or sulfur by 90, and NOx by. And last sentence, but most important, every 1% increase in pellet Fe in the blast furnace increases its productivity by 2%, and coke rate is reduced by 1%. You all know, friends, that India does not have adequate coking coal, so we have to import the entire coking coal. So saving in coke rate means saving in the foreign exchange. Next. So this is some statistics of decarbonization, that we require about 20 liters of furnace oil, or 2 lakh kilocalories is used for making 1 ton of pellet. This is a very important benchmark. We have to improve on that benchmark. Carbon emission varies from 0.58 to 0.65 tons per ton, depending on the mineralogy of ore. Higher Fe iron ore is becoming lower and lower. So we mean low and lean grade iron ore fines we need to beneficiate and then agglomerate. Beneficiation of low grade ore will also result in reduction of SiO2. As I mentioned, silica and alumina are biggest enemies of our iron making. So we require lime and dolomite to flux them. So last sentence is important, that every 1 kg of reduction in flux will result in 1 kg equivalent of carbon dioxide emission reduction. Next. Now, the need for beneficiation has been highlighted by many people, but the main thing is that because iron ore Fe is decreasing, we need to beneficiate. One fact very few people know is you cannot charge a Fe content of less than 60% into making pellets. You need at least 60. The thing is at least 61%. I am in a committee of Bureau of Indian Standards, which are standardizing, it is called MTD 13, which are standardizing the use of iron ore for blast furnace. And I have been advocating on behalf of PMEI that we need to reduce the cutoff, because we won't get, all the big people are asking 62% Fe, but in the times to come, we will not get 62 Fe. So we need to think about this. Now, national steel policy envisages this. Everybody knows these figures. So we require about 437 million tons to produce of iron ore and pellets. So the use of low and lean grade iron ore fines through beneficiation is the need of the hour. So this is, a lot of studies are going on. In fact, an IBM report says that beneficiation is the need of the hour, and the government of India, Ministry of Steel, has to encourage beneficiation. This task force on material efficiency, in which I'm glad to inform you that PMEI, we are members of this, and we are trying to give a paper on what will be the impact of reduction of carbon if we use more and more beneficiated ore. Next. Now, these are some suggestions on iron ore beneficiation. The royalty rates, as my friend from NMDC just pointed out, we need to rationalize. The royalty rate right now is almost 20%, because 15% is the royalty, plus there is a district mineral fund and all that. Ultimately, it comes to 20%. So it has to be rationalized to around 5% to be at par with Brazil. Then amendments in all these acts, I'm not going through. The beneficiation can have the flexibility to beneficiate ore from multiple mines, because there are many mines. We need to set up beneficiation plants near to the mines. As of today, most of the beneficiation plants are far away. So I think in times to come that the beneficiation plants has to be situated near to the mines, and we have to have adequate land to dispose tailings. And then, of course, a lot of tax holidays, financial support. Next. So these are some of the suggestions I wrote to all my members. We have 27 members. So these are the summary of the recommendations made by our members, that land for disposing of tailing, that government has to give at subsidized rate. At market rates, if they buy land to dispose kachra, you can imagine what a colossal loss to the country. More iron ore mines need to be auctioned. Right now, the auction process is very slow. We have appealed to the Odisha Mining Corporation to do auction every 15 days. So these are some of the things which Pellet Manufacturer Association is helping. Pricing of low-grade iron ore has to be reduced. You can't expect an ore of 5,000 rupees to be washed and produce pellet. They can't. This is impossible. So the pricing of low-grade iron ore, the government has to take care. Traders has to be restricted. Right now, there are a lot of traders. Right from the situation in tomatoes in the country, traders have to be restricted. Especially, they have to be restricted to participate in the high-grade iron ore Fe content action. This is a slightly sensitive topic. I'm not going into it, but mines should be reserved. Actually, right now, it is an open auction. So I personally feel from PMAI that iron ore plants and iron ore beneficiation plants, some mines should be reserved from them. Then more non-operational mines need to be auctioned. This is a very typical example of Indian policy making, that the right hand doesn't know what the left hand is doing. So we need better coordination between the state governments and district level authorities. Next. So I'm quickly running out of time, so I'm just increasing the speed. These are all the beneficiation capacities in India. They are all well known. Next. There are several issues in beneficiation. Most of the we have around 100. What we need to do is make the existing beneficiation plants more economically viable. How do you do it? Because two things. One is to keep the iron ore price lower, much lower than the present, especially the fine ore price. And the water requirement is very heavy, 1.5 cubic meters per ton. So we need to develop some dry beneficiation techniques. 60% of alumina is associated with goethite, and that requires very fine grinding to less than 100 millimeter. Beneficiated ore is becoming more and more costly, low availability of land, high power cost, energy consumption per ton of concentrate is very high, as I'm saying. And then, of course, ultimately, the IBM report says that the government of India should have more incentives for beneficiation. Okay, next. What are the opportunities in pelletization? As you say, that right now it is 0 to 25%, which gradually needs to be increased to say around 50% by financial year 2030. And this will happen. This will mean about 126 million tons to be charged in blast furnace. The share of pellets has to be increased to around 65%. Right now, average is around 35%. And the projected pellet production by financial year 30 is around 200 million ton. I'll show you in the next slide. This slide is slightly, there was a little typing mistake. I just want to correct this, that the JSW, Tata Steel, they are two different entities. JSW, as everybody, all the members, all the participants know, I'm sorry for this slight mistake in typing. JSW, I'm just reading out what is the capacity. JSW 66 million ton, the largest pellet capacity in the next 10 to 20 years. Tata Steel, our Inderjeet Paul will confirm, around 24 million tons. ArcelorMittal is correct, 12 million tons. Steel Authority, they are setting up 24 million tons, like that. So the total is the same, 320 million tons of pellet capacity is coming up in the next 10 to 20 years. This is the best news for this country. Atmanirbhar in pellets. Next. Now just see what are the issues, what are the challenges. The biggest challenge is high price of iron ore in Odisha. This is really very sad. We have been writing letters after letters. The OMC, Odisha Mining Corporation, our friend from NMDC is sitting here. My humble appeal to him is that right now, NMDC and OMC, they are the biggest kingmakers in iron ore supply. They have to rationalize. They have to make a reasonable margin so that the pellet industry does not suffer. During the last 6 months, pellet prices have crashed by 11%. From around, international is around $116, but right now it is around $100. And the pellet price are decreasing. As you say in the next slide, the drop is very, very large. So we need to increase the, the capacity, the pellet prices. We have to reduce the price of iron ore and the increase of price of pellet. Next is we have an overcapacity. Now, this is one thing which the government of India has to do. Our big players, like for example, in the last year, 37% of pellet capacity remained unutilized. It is so sad in a country like India, where people have invested thousands of crores in setting up pellet plant. You are just not utilizing 100% capacity. Why is that? The biggest reason is the domestic market is not adequate. We just use around 80 million tons. What do you do with the rest? 50 million tons. One is, of course, we can do export. Last year, export was hardly 6.3. Before that, it was around 13 million. Why? Export market, export is a competitive thing. China, Vale, Brazil, they are crashing the prices. As you can see, from April to 22, price crashed from 179 to right now. In fact, today's steel mint says it is $107. So this is sad. We need to do something about it. We can't do anything about international process, but we can certainly, my friends from Steel Authority of India Limited, who are sitting here, who may be there, you can convey to them by word of mouth. Like our ex-chairman, somehow he couldn't join, Mr. Chaudhary, Anil Chaudhary. He would bear me out that unless Steel Authority of India uses pellets, okay, they are in the process of setting up new pellet plant. Now that is really ironical. We already have 130 million tons of pellet capacity. Why do you want to set up new pellet capacity? Why not use the excess pellet capacity? This makes sense. So my humble appeal is that kindly plants like SAIL should use the existing pellet capacity. Some suggestions for the pellet industry. I'm quickly going through. The Ministry of Steel is requested to kindly take up the matter with state governments, particularly Odisha, for rationalization of iron ore mines, from OMC mines, for survival of pellet plants. It will be a win-win situation. The state government will get royalty and sustain livelihood for about 2 lakh families of Odisha, West Bengal. In fact, you all know they are the poorest, among the most economically poor states. This has been a very good, the para number 2 export duty has been removed. So it has to be there. Consistent policy in iron ore pricing. Right now, it is every week the prices are changing. If somebody follows the steel mint prices, every week the price of iron ore is changing. The 4th is policy on incentive for decarbonization of pelleting. Soon the world will put an embargo on how much carbon you have used, how you emitted. So we need to be prepared for that embargo. You already know that the European Union has come up with another embargo now. We need to set our own house in order. Next. I have already mentioned that the royalty of iron ore needs to be revised. Encouragement needs to be, this is a very important aspect. New technologies have been developed by CSIR labs like IMMT. You must be knowing IMT is a national CSIR lab. It is in Bhubaneswar. Then we have labs like National Metallurgical Laboratory. So they have developed technologies for new beneficiation technologies. we need to upscale them. You see, upscaling a pilot plant requires hundreds of crores. So my humble appeal to the Ministry of Steel is that they need to partner with these CSIR labs and of course, in a PPP mode, I'm from PMAI, our pellet plants will also contribute. Let us develop technologies together. My last appeal, our Prime Minister says, Atmanirbhar Bharat. You will be surprised, gentlemen, most of our pellet plants, almost all, are imported, either from Germany or Japan or China. We need to set up our own indigenous capacity in design, engineering, manufacture of pellet plants and beneficiation plant. All of you have heard of companies like Mekon. I'm not a marketing guy for Mekon, but I know their capability. They have recently built the largest pellet area of JSW. So that is totally indigenous. We have companies like MN Dastur. We have companies like Metso. We have Autotech, FL Smith. They are all international players, but now they have set up in India. So I'll conclude with two photographs of pellet plant. This is at Chhattisgarh. The other plant, it looks green. Pellet plant is quite nice and green. You see a lot of trees in Odisha. And last but not the least, we have our address of Pellet Plant Association of India. We are 20 members and we are in Defense Colony. Those of you who are listening to this PMAI office, kindly note down this address and our email ID. Who have helped in this presentation, particularly in gathering a lot of facts and data. Thank you, gentlemen. Thank you.
Thank you, Mr. Bhatnagar. Thank you so much for an excellent presentation. I am sure most of the people who are watching us either on Zoom or live on YouTube will surely want a copy of this presentation for their benefit. So they are most welcome to write to Mr. Bhatnagar with the email address that is given on the screen, or you may also get in touch with us and you will get a, I will try and see if Mr. Bhatnagar is willing to share the presentation.
We will certainly agree to the request, but let people write. So we generally want to be a little restrictive. Yeah.
So let everyone write to you and you can choose whom to send and whom not to send the presentation. So I leave it on to you. Now we have a solution provider. Mr. Bhatnagar gave us the challenges. Now Dr. Lamke will give us the solutions which we need to adopt for the pelletization units in this country, and also to take the pelletization industry forward in terms of modernizing them, in terms of expanding them, and to meet the challenges of the growing demand of pellets in this country. So over to you, Dr. Jan Lamke, Technology Unit Pelletizing Manager from Haver and Becker Niagara, who is right now in Germany. So
thank you.
Dr. Lamke, it's over to you.
Okay, thank you. Thank you on the one hand for the opportunity to talk to you. And as well, thank you, Mr. Bhatnagar, for your very interesting insights into Indian iron ore market and pelletizing market. And I would like to highlight your first words, value addition, by agglomeration, or let's say by pelletizing itself. And this is something I would like to discuss within the next minutes. I'm from Haver and Becker. We are a typical mid-sized German based company. We are with 3,000 employees all over the world in processing, storage, mixing, filling, packaging, and loading, pelletizing. I'm in the area of processing. And in those fields, we are handling screens, pelletizing discs, washing equipment. And today we are going to discuss more insights about iron ore beneficiation in total and pelletizing in detail. Coming up with a quite old flow sheet. Anyhow, it is still pretty common and existing in the beneficiation of iron ores. Most probably the run of mine material starts, of course, in the mine, and in several mines we meet up with a scalping technology there. So holding eyes open, I'm pretty sure all over the world you will meet screens with the scalping technologies, screening in the area of cut sizes 300 to even 500 in order to bypass the jaw crusher. After the jaw crushers, let's say between the jaw and the cone crushers, there are cut sizes in the area of 80 to 100 as well from Haver screens in, with capacities with more than 500 to 1,000 tons per unit and hour, of course. After the beneficiation, of course, there are several fine screening steps depending on if the material is going to be pelletized or sintered. Depending on this, there are different cut sizes, could be in the area of 6.3, could be in the area of 1 leading the materials to concentration plants later on. As well, lump screens. Lump screening, this is a pretty old technology you know about, with the blast furnace feed. Anyhow, still existing in many parts of the world, and there are some, let's say for some reason, still existing. Typical cut sizes in area 5 to 50 We are going to discuss today pellets, that leading to the fact not only the pelletizing disc need to be discussed, as well the fired pellet screening need to be discussed. Therefore, our screens could be used with temperatures most likely in the area 250 to 300 degrees Celsius. Anyhow, we even supply screens with up to 800 and 900 degrees Celsius of the pellets. And today we are focusing the pelletizing discs. One short slide about the basics of pelletizing. I'm pretty sure all of you know there is the need to feed fine-grained particles, the concentrate itself, most likely below 100 most likely the average PSD is in the area of 20 to 30 micron. And those materials need to be mixed with binders like bentonite, like organic binders or mixtures of those. And while adding water or having water in the pellet feed by the rotation of the pelletizing disc, a process chamber which is inclined by typically 40 to 60 degrees to the horizontal, the material get into a movement to create those round shape balls, and due to the segregation effect, a very tight particle size distribution is going to produce in a pelletizing disc. Having a look into the influencing parameters of the pelletizing disc, we easily see the rotational speed, the inclination, and as well the depth of the process chamber, let's say the rim height, are influencing parameters which needs to be analyzed on the one hand and needs to be controlled on the other hand. Of course, the addition of the material itself, the capacity of the equipment, and the addition of moisture are influencing parameters as well. But of course, most of our customers like to increase the capacity at all. We can't say. They would like to increase the yield and the production, and therefore it needs to be optimized the capacity of the equipment, and they would like to decrease the moisture content, of course. Getting in and asking why, this is a quite typical flow sheet of iron ore pelletizing plant, which consists of course, a lot of bins with the concentrate itself, additives, binder, recycling load of the material needs to be mixed, add into the pelletizing disc. Thereafter, the roller screens we saw in the movie in between, and then the material needs to be integrated or in order to meet the requirements of the blast furnace or even the direct reduction. Coming up to the situation, most pelletizing discs do not produce a yield of 100% in the area of 9 to 16, which is quite typical for blast furnace, or 10 to 14, which is pretty typical for DR plants. So there is still a recycling load of oversized and undersized materials. And by the way, of course, it is a need to decrease the content of the oversized, undersized materials by increasing the product. How to act with, we are going to have a look in right now. Some words about why Eva Böcker is in pelletizing, since I'm not very sure in more than or longer than I'm in the company, but let's say more than 60 years right now, and especially we are in iron ore pelletizing. This is a view into a quite typical pelletizing plant, which is here based in Brazil. 7.5 meter disc are very common in typically 150 tons capacity, and with those 150 tons capacity reaching out a yield or a production of 70% is pretty common. In the opposite to the pelletizing discs, there are existing pelletizing drums as well. And with the drum pelletizers, this is a picture from US anyhow, typically diameter.
Dr. Lamke, if I can just disturb you for a second. Your screen is not changing, so you have stuck to the first slide. You are not visible.
Really?
I mean, the slides are not visible, so you are.
I am still feasible, yeah.
You are visible, but only the first slide is there, so you are not changing the slides. Okay.
Sorry, yeah. I won't show me. I would like to show the slides. Well, what about now?
Yeah, now it is there, but you have to go full screen now. It is still not full screen.
Okay, now just a second.
You have to make it full screen.
Yeah, the problem is the Zoom. Yeah. For now, better.
Yeah.
Oh,
yeah, perfect. Now it's fine.
Sorry,
yeah.
So you missed some very interesting slides. Anyhow, I showed you pictures of.
You can quickly go through the old slides which we missed.
I will be very quick. Let's discuss this issue here. What I discussed with you, every pelletizing disc produces part of oversized and undersized materials, and of course it is necessary to increase the production by decreasing oversized and undersized materials, and therefore pelletizing discs with changeable influencing parameters like rotational speed, like inclination, even with changeable rim height, are a good tool for. This is quite typical for pelletizing disc-based iron ore pelletizing plants, 7.5 meter in diameter, reaching out a capacity of 150 tons per hour with a yield of 70%. And in the opposite, this is a picture from US pelletizing drums, which produce quite good pellets, we have to say. Anyhow, the yield of those equipments are really worse. So 25% up to 30% yield is pretty common. So at least you have to produce or need a capacity of 400 tons per hour to produce the 100 tons per hour of product. But now let's have a look into the latest generation of pelletizing disc, and this is indeed the disc with a changeable rim height. Why the changeable rim height? With the change of the rim height, you can easily change the retention time of the material inside the process chamber. As longer the material is inside the process chamber, the pellets could be a bit bigger, or if you need to produce smaller boards, it is easily possible to decrease the rim height in order to decrease the retention time, and by this the diameter. So you can easily change the particle size distribution only by the rim height. Of course, it is possible as well with rotational speed and inclination, but those parameters leading to the fact as well that you are changing the width of the PSD. So what does it lead to? We can see here in animation the use of different parameters of the equipment, and only by those parameters it is possible to change the PSD. We have in mind the value addition, and we have as well in mind the situation that there are still plants which are not producing in let's say 100%, and for this reason, plus the situation that the iron ore price is quite deep yet, it is always necessary to run the plant in an optimal mission, and that leads to the fact decrease of the recycling load is very necessary. How to do so? With equipment like this, with a high number of parameters, it is possible with the Scarabeus process to produce higher quality pellets, especially necessary for the DR process, which are significantly tighter in the pellet size distribution. This is very important. And as well, which is important, that the operators can, let's say, serve the process with a range of the influencing parameters of the equipment, and not only by, let's say, change of the material, adding more additives, adding more binder, or adding more moisture. So, and this is a very important fact. Next benefit is the increased product output. As I've told you, by decreasing the recycling load, it is possible, depending a bit on the parameters, but in a plant in Ukraine, it was possible for us by BF pellet production to increase the production rate of the unit by 30%, and even for DR pellet production, it was possible to increase by 50% the yield. And of course, in the end, then we showed, and this is very important for Europe, for US, for Brazil, and for India, China, of course, as well. For you, you named the year 2070 to reach CO2 neutral. And these pellets giving the possibility to work with the DR plants in a good and reliable way, with a very even PSD of the pellets. This was a very short introduction into the pelletizing discs for iron ores. We can see here a short animation about the changes, and this is very important. Those changes, all of them are possible on the fly. That means there is no need to stop the equipment in order to adjust the inclination or in order to adjust the rim height. If you recognize there is a need to change something, it is just by pushing a button possible. Why it is necessary? The equipment needs to process natural materials. Natural materials could even have some fluctuations on the one hand, and on the other hand, you have several customers. Several customers we saw as well in the morning. No, sorry, it was my morning. We saw some hours ago. There are existing different DR plants, and different DR plants, of course, having different necessities in the pellets, acid pellets, basic pellets, the size of the pellets, and so on. So more and more campaigns are necessary. I'm very, very sure in, and therefore it is necessary to be flexible with the plant itself. As we can see here, this new equipment looks like a kind of a UFO, which is landed in a pretty old plant. This is a picture of Ukraine. They have several of this Scarabeus technology pelletizing discs in. And to be in time, I would say I will stop the presentation right now here, even through, and this is important as well. I would like to show you one slide too. alternative material streams, and this is something I'm pretty sure we will be faced pretty soon in. For now, many materials will be feed back via recycling onto a steel belt in front of the blast furnace. No blast furnace, leading to the fact, no steel belt, leading to the fact there are alternative routes for recycling of different materials. And this is the fact why we recognize in many requests right now, not only the request for iron ore pelletizing discs, these kind of 150 to 180 tons per hour. As well, there are a lot of requests for smaller capacities with special materials like iron oxide or lead and zinc based materials. And of course, therefore, are pelletizing discs as well available with smaller diameters. We see here 4.2, here 5.2 meter diameter pelletizing disc in metal oxides. Of course, due to the material, there is a need for special materials. Those materials could be recycled in weld kilns or in bath melting furnaces. There are many possibilities in. And if you like to, we can go smaller as well, up to or down to a laboratory scale pelletizing disc. Anyhow, more or less 2.2 is the smallest production pelletizing disc in use for several materials. Could be in lead, could be in iron oxide, could be in zinc in. And yeah, that's all for the moment. What I forgot in the very beginning, we are not only based in Germany, we have subsidiaries all over the world, and three of them are in India. We have subsidiary in Vadodara, Gujarat, in Delhi, and as well in Kolkata. So if you have any questions of course, you can come up to me or you can come up to Mr. Ananda Mukashi. So thank you. This was pretty brief, but thank you for the possibilities to talk to you.
Thank you, Dr. Lamke, if you can hear me. Thank you.
Yes.
Though we missed a few of your slides, you were kind enough to go back and repeat those slides. Thank you so much. In fact, so much so that I would request all those of you who have any questions to kindly ask Dr. Lamke if there are any questions. Kindly raise your hand if you have a question. So I think Mr. Bhatnagar has a question. Mr. Bhatnagar, please go ahead and ask. Mr. Bhatnagar, your question, please. Mr. Bhatnagar, are you there? Okay. Dr. Saikat Samanto. Yes, Saikat, please go ahead and ask your question.
Yeah, so thanks for the nice presentation. If I understood correctly, that there are two things which is controlling beyond the conventional pelletizing disc. One is the disc angle. Yes, it depends upon the angle of repose of the material. I agree that if you change the inclination, then you can produce more productively within the desired quality. And the second is the rim height. So you can change the height. So what is the intention to change the rim height? You want to produce more or you want to produce less? Or you need the correct size? The intention behind the rim height change?
I would answer this question, let's say commonly for the very beginning. We recognize many requests for proposals giving up the situation to say, okay, nominal capacity of a pelletizing disc is in the area of 100 to, or let's say 130 to 150 tons per hour. And design capacity should be in the area of 200 tons per hour. I'm pretty sure all of you will agree with the situation. It is always possible to send 200 tons per hour through the pelletizing disc, but you will never meet your 9 to 16 or 10 to 14 mm. as the retention time of the material in the process chamber is too small. You are only able to produce small granules in the feed size of a sinter plant. This on the one hand. Now we have the idea what is the influence of the retention time, how long the material is in the process chamber. And this is exactly the point. We thought about what are the parameters to change the time in the process chamber. At least, of course, the capacity, but the pelletizing disc is not a standalone equipment. There are several pelletizing discs feeding the furnace or the induration furnace. And most likely you won't change the capacity of the furnace by several reasons. So hold the capacity constantly. How to hold the capacity constantly and change the retention time? Therefore, it is a necessity to change the volume of the process chamber. We can do it by change of the diameter, which is technically not that easy. So we decide to act with the rim height.
Yeah, that could be possible with RPM, but in that case, your rejection will be high, right?
Totally right. By RPM, of course, it is possible. For example, by decreasing the RPM, the kidney will change from the position of, I have a look onto my watch, from, let's say, which is typically 8 to 9. By decreasing the RPM, it will come to maybe 6 to 8. With this, you have less materials in the process chamber, on the one hand. On the other hand, I'm pretty sure you know the calculation of the critical speed, which depends on the inclination of the process chamber and on the RPM. And with this, it is not only possible to change the size of the pellets at all, it is as well possible to change if you are going to produce a very tight particle size distribution or more with particle size distribution. And of course, but this is not very new in a lot of influencing parameters giving to the operators, leading to the fact you have to know which parameter is necessary to be changed at first, second, or how they influence each other. Of course, we are using camera systems and AI-based technologies to optimize the process by itself.
Thank you very much.
You're welcome.
Okay. I think Mr. Shams Yadav has a question. Can you please post your question in the Q&A section so that Dr. Lamke can answer it? Can you post it, please, Mr. Shams Yadav, in the Q&A section so that we don't really waste much time in answering it live? Have you posted the question? I can't see it. Dr. Lamke, can you see any question? I can't see.
I can see some questions. For example, can we change existing balling disc to this one? Yes, this is possible. And this is what we've done as well in other plants. So this is not the equipment which needs to be in a total new or greenfield project. Even in brownfield projects, it is possible to add this technology in.
Okay.
So but anyhow, you see my contacts, you see the contacts of my, which is my colleague, Mr. Mukashi, who is the business development manager at Hafa IBAU India. So please contact him or me and we can reach out, I'm pretty sure.
Yeah, Mr. Anand Mukherjee is based in the city of Kolkata. So those of you who wish to get in touch, in fact, Mr. Mukherjee is located right in the city itself. So if you have, Mr. Shams Yadav, you want to ask a question?
Yes, sir. Good evening, sir.
Yeah, please go ahead. Please identify yourself and answer.
I'm having this question here. Now, sir, presentation was very nice, sir. The ream height, the blend number of concentrate having any impact on the ream height?
Oh, sorry, I didn't get which impacts the rim height?
Concentrate blend number.
The plane.
Blend number.
No, we go really deep in the theory. Yes. Indeed, as finer the material, most likely we can say as fine the material, as better to pelletize. Anyhow, if we reach up to 2,800, or let's say starting with 2.5, it becomes worth to pelletize. And for this reason as well, we can use with the rim height to reach out with a deeper rim. Due to the deeper rim, the pelletizing disc become into, let's say, something like something between the disc and cold pelletizer. So longer way to run on the rim.
Okay, does that answer your question, Mr. Yadav?
Okay, thanks. Thank you.
Welcome.
Okay, now I'll move forward with my good friend and my
Thank you.
brother, Shoikat, a good friend and a brother, Dr. Shoikat Samanta from Neufert. AGM AGM process and sales, Neufert GmbH. So over to you, Shoikat, for your presentation, followed by Mr. Priyaranjan Prasad from Germany River Pellets Limited. So it will be a back-to-back. Shoikat, followed by Mr. Prasad. Yeah, Shoikat.
Are you able to see my screen? Hello?
Yes, we can see your screen, Shoikat. Please go ahead.
Yes,
Okay.
we can see your screen.
Yeah, thank you. So first of all, I would like to thank you, the organizer, for providing us and giving us the opportunity to participate in this webinar. So let me introduce myself. I am Dr. Shoikat Samanta. I am based in Kolkata. I am working for Neufert GmbH, and we are based in Esbon. So most of the colleagues are based in Germany. So we'll be talking about various aspects of pelletizing, and as you know that we are Neufert, so we would like to bring some new topics or new subject to bring you update about the new developments of Neufert in the pelletizing industry. So I would take to you some slides. First of all, as you know, Neufert is a younger company, and we say that we are old wine in the new bottle. So we would like to take the opportunity to introduce about our company in a few slides. I will go very fast on that. And then we will go through the how Neufert is providing the services and supplies in the pelletizing as well as the beneficiation industry, and some few developments and new challenges in the Indian steel industry, which is covers two different subjects. And last but not the least, on the advancement of the control and the measurement solution, which is most related to the beneficiation as well as the pelletizing industry. And finally, on the development in the pelletizing, and not the last one would be the reference from our end, what we are doing now globally in our Neufert company. So if we say about the Neufert, the first things what we say that we are providing our services in excellencies in the beneficiations and agglomerations. So in general, Neufert offers the design, manufacturing and procurement, supply, installations and commissioning and optimization, especially in the field of iron ore beneficiation and pelletizing plants. So we cover both the agglomeration technology as of now in the industry. So even in the beneficiation part, we do have. As I said that we are based in Esbon, and our company is younger, is established in 2019. 3 iron ore industry professional with vast experience in project development and implementation of beneficiation agglomeration projects. So we are there in globally. We are in Germany, in India and Brazil. Our office is downtown of Frankfurt, which is 15 kilometers from Frankfurt Airport. Now coming to our network and cooperation, if you see in the all continents, you can find Neufert representative and our engineering partners and as well as the specialists. And we are also tied up for our developments through various universities, and we do our testing in various established laboratory around the globe. So this slide is showing our network throughout the globe, so where we have presence and we are working in different continents too. Now coming to the what we do actually in Neufert, what service we are providing and what we can do for this industry. Now coming to this entire value chain of the project implementation, is starting from the conceptualizations, design, and in all disciplines we can provide you the service. You can name it the process engineering, plant mechanical, piping, E&I, everything we can do. We can also do is purchasing support, we can do the commissioning advisory support, we also do the project implementation, and we can jointly also work for the R&D development project also. So in the all segments, we can contribute to the industry. If you need any special kind of requirement, please feel free to do contact with us. Now coming to this thing that what Newford from Newford. So Newford is providing the technology package, and we are not rigid in terms of our technology supply. What it means that we are not like providing you the full package. We are very much flexible in terms of our offering. It means we can do studies, we can do the test work for you, we can do only the basic engineering for the pelletizing and beneficiation plans, we can do only the furnace design, and we can also do the package integrations. And as well as based on the requirement of the client, we can also do the key equipment supply. So, and as well as if you need, if from your own source, you can do your project, we can also do the advisory and supervisions for implementation of the project. So this is the one of the most important USP of Newfar, where we are not rigid in terms of any offering, but we are quite flexible to do any kind of support in during your project execution. Now, while we are talking about the supply, we know that most of the supplies are coming, the critical supply is coming from the imported one. And while we are talking about the Make in India and Atmanirbhar Bharat, so Newfar is quite flexible in terms of manufacturing, inspection, and developing the manufacturing facility in India. It needs not to be all the critical equipment which is very much wear and tear in nature that you need to bring out from the foreign. We can jointly develop for India that will substantially reduce your capex investment as well as in the opex in terms of spare parts. If you see in the left side of my presentation, where you can find the most critical equipment which you usually need for a pelletizing plant, and we can do support. If you need some supply from our end, we can do also, or if you want to procure it from the global established supplier, we can also do support in this regard also. Even having said that, we can also develop in India to be more Atmanirbhar and to bring down the investment in that regard. Now coming to the design improvement. So as we are now talking that the 37% of the pelletizing plant is underutilized. So we know the dynamic behavior of the pelletizing industry. The price is go and down. So how to cater in such a situations? We can do only because if we can reduce the OPEX is coming mostly from the fuel. As you know, 50% of the conversion cost is coming from the fuel. And to minimize the OPEX, we have two probabilities. Either you do the less specific consumption of your fuel, or you can use the less price fuel. So here we are now thinking, and we are now implementing this low calorific gas as a fuel with a hot air cooling system in one of our Indian project. What is means? In generally, we know that for a pelletizing plant, the fuel should be around 2,000 to 300 kilocalorie per nm cube, whether it could be blast furnace, Corex combinations, or unique kind of mix of natural gas with a low calorific gas. But what would be the coal gasification? We talked about today more about the coal gasifications, and here comes the Newfar solution. If you have the producer gas which can have 1450 to 1500 kilocalorie per normal meter of calorific value with this desired quality. Obviously, you need to find what is the impurities, what is the pressure, what is the quality of this producer gas. So that can be used, and this can be used as a combined fuel with the low sulfur heavy stock or any furnace oil that's subject to depend upon the sulfur emission. So it means that you can use producer gas as a fuel in the pelletizing plant. That way you can reduce your OPEX cost. And for To use such a low calorific fuel gas, you need to have a hot air cooling fan. I will explain what is hot air cooling fan. If you see in the right part of my presentation, where you can see that the last part of the cooling zone, there is a line which is going, this is, we call the cooling zone 2 air, which is going to the UDD area. We need a bypass from that, which is substantially 300 to 350 degrees centigrade, and we can take that high temperature of gas, which will be mostly off to the ESPs, that can be used as a hot air cooling purpose. You can see here is a 350 degree. This is just after the after firing, where we take a bypass of, or the connection from the UDD gas duct to the after firing first cooling zone. So by doing that, what is the important? By doing that, we usually think that we will definitely increase the DR main temperature. And if you have the high DR main temperature, which is mostly 50 to 100 degree, then you can substantially lower your fuel consumption. As I said, there are two ways to do. One is the use low fuel, and you can use the low priced fuel. So why having this hot air cooling fan, you can minimize your specific consumption, means you can do the OPEX cost substantially low. And in that regard, it is not only about this fuel consumption, it can enhance your product quality. So if you know, when in the after firing, the pellets is 1250 degrees centigrade or 1200 degrees centigrade, you are not cooling that fired pellet or the hot pellets with the ambient air, which is close to 20 or 25 degrees, but you are cooling that with 350 degree or 300 degree centigrade air. So you are not, there is no thermal shock, means you will have less crack, and less cracks mean you have better uniformity in terms of the CCS and other physical parameters. So having that, this low calorific fuel gas as a fuel, you have to have the fuel and the hot air cooling fan in the system, because you need to maintain the oxygen level into the furnace, because as we know that induration is a oxidizing process, we need to maintain certain oxygen level. So in that regard, hot air cooling with the low calorific value producer gas, we can use in our pelletizing plants that can be retrofitted in the brownfield project as well as the greenfield project too. And we are executing this project for our esteemed customer Lloyd, which we are now undergoing 2 into 4 million ton pelletizing plant in India. Now coming to the developments, when we are talking to our operators and maintenance people, they are facing so much problem in terms of, in that regard, Nufor had thought to develop some of the critical equipment and arrangement in the pelletizing plant. We know from our traveling at technology that we have seen some brown plates are coming at the site wall level. So can we develop this feeding arrangement so that we can have more fired pellets as a product? We have no too much deviation in terms of CCS. So in that regard, I can say Nufor has developed a feeding arrangement. You can see in the top right, where you can see the new side layer separator, which is a delta cut. By having such a new arrangement, you can reduce the friction area between green pellets and side layer separator. You can optimize your feed of side layer so that you need not have any brown pellets in the dead zone of the pellet car. So you can fire that pellet with much higher temperature that could produce you uniformity in terms of CCS. And having this arrangement, it is not only about the side layer, you can have more in terms of your maintenance, in terms of your cleanliness of that area, and you can adjust the slide gate accordingly with the new arrangement. So we have improved this particular area with such a new design. We have designed this, we are going to implement such arrangement in the coming plants. So as we know, this is all about the feeding arrangement. Now, as we know, the pallet car, we have developed a pallet car. You can see in the left part of the bottom, the conventional design, and in the right part, you can see the Nufor design, where you can see the grade bar, which is more than 10% of open surface, mean you have better permeability in your bed, so you can fire, you can do your firing faster. So in that way, we have improved the pallet car design. I'm not going all the points, but the message is that we have already improved the pallet car as well as If we see about the wind box, which is taking out the air from, or suction the air, or to put the air into the system, if we say that in the slide we have developed our wind box design also. We know there are some dead zones, but we have trying to consider our design to minimize the dead zone. And you can see from here also, we have in our design we have two spillage chutes from each wind box. It's not only one double pendulum flap, it is the two pendulum flap is a single wind box. Means in terms of aerodynamics, in terms of the maintenance, in terms of the spillages, we have much better design to cater the challenges which the operation and maintenance people are having in the plant right now. Now coming to this is all about the pellet plant. Now we are talking about the decarbonization, we are talking about the hydrogen use and the green steel. So to have this in the future, we need a DRI and a EAF system, that for sure. For to being the DRI quality pellets, we need better quality of concentrate. Means we need high Fe content, we need low gang material in the system. In that means that we need more beneficiation or concentrate or the developed technology to upgrade the low concentrate material to the high grade. We need high grade pellets for sure. So in that regard, we have teamed up, Newfar has teamed up with SEMI, one of the pioneer of the digital product, where they contribute a significant in the Brazilian market. We teamed up together and they have developed such a nice product in terms of the advanced control and measurement solutions. If you go in the downstream, so we'll talk only majorly on the 4 different product here. As you know that the pellet size distribution measurement system, this is on the top of the discs, or you in the discharge part of the discs on the top of the belt conveyor, you can put this. We have this run up mines orge distribution. This is all online measurement system. We can do the size distribution of the material, and we can also know the grade measure. I will come down in the subsequent slide about the details about the what exactly this equipment is working. So all the equipments are on mainly the online at the site, and this is the level 1 automation, and we do have the advanced process control as well as the dynamic simulation, which is the mathematical model. This is the level 3 operation, level 3 automation, which is interlink the level 1, and then on the level 4 we have the data storage, which can use for the future data analytics and the historical information from the plant. So in that regard, what you could say, if you see in the slide, we have a camera system which is just at the discharge of the pelletizing disc. What is exactly do? It takes the pictures from the discharge part, and it will give you the exact the diameter of the pellets, what is producing in terms of the 9 to 12 millimeter or 12.5 to 60 millimeter. Any PSD you will measure immediately, and it will give the feedback, and it can be controlled to the feet and as well as the RPM of the pelletizing discs. This camera system can be also established and can be installed in the above of the conveyor belt also. You can also detect the size distribution above from the white belt conveyor also. So this is a proven technology, and SEMI is already given this solution to the Brazilian market, and they are already 12 years in the market with such a solution. We are pleased to inform you that we are going to establish this product in India, one of the pioneer pelletizing plant. We are now executing that project, and we are supplying this solution to that customer right now. Now coming to the how the software look like, you can see in the right part of the slide, as I said, that it is a camera-based, vision-based installation, which takes the pictures of the pellets and it's measured immediately diameter. And if you see in the bottom there is a histogram, you can see that what exactly the my pelletizing disc is producing. And as I said, it can also be controlled through the parameters. It can be with the moisture addition, it can be with the RPM feed, it can be also with the additive additions also. So this software will immediately collect the information, and there is an interface to communicate to the DCS. It can immediately control, and from the control room, the operator can control, or the operator can see that the exact operation or the productivity of the pelletizing disc too. And as I said, that this is the new great measurement. So if you see the installation in one is the Brazilian plant, what is exactly do? This is a equipment which can measure the grade of the let's say the filter cake, the slurry, the material which is conveying. It can take the online sample. It can immediately give you the results. What are the composition of the material like Fe, silica, alumina, the major oxide you can detect online and give you the immediate results. As before I said, the software will immediately connect to the DC system so that the process control things can be done immediately, not waiting for the chemical results from the lab. We know that from silica, alumina, it needs a longer time to get the analysis. But having such a equipment at site, you can do the online measurement, you can have the results, and you can control your subsequent process equipment accordingly. And having said that, this is not only the measurement in the APC, which I'll come to the next. So you can see how the control, this is the adversary software, how can you control the process parameter altogether. So if you see in the slide, where we have just taken a snap where you can see that Fe silica, how it is changing in terms of your feed. And this is very much applicable if you have, let's say, various kind of sources. You don't have a control in your mines. You are not the captive mine user, you are merchant, but you have not your own mines, then you have no control over the product quality. So such kind of installations, online installations, can bring you immediate information about the quality. And it can also measure the size distribution. It can also measure the density. It can also measure the other parameters if you need, like the blend number, correlation of the blend number, the all other parameters which exactly you need to control the process parameter. So having said that, this kind of online measurements, what we'll do, so it's all about the measurements. Now we have a advanced process control software. This is the level 3 automation system where the software can do the advisory tool. It can take the measurements from the field. It can analyze it. It can guide the equipment, process equipment to control and to give you the more productivity, or to bring you the best quality out of from your ore. So this is the advisory model. This can be installed, as you said, you can do it in the concentration plant. It can do it only for the grinding, mixing, green balling in duration. Depend upon your requirement, it can be installed in any of the part of the process areas, or you can club the all areas together to have a holistic advisory tool in your plant. In that way, you can control. We know that manually it sometimes is very much difficult to control the process parameter, but this software combined with the measurement equipment at site could really help you to gain the high grade material in your plant, which is leading to the high grade pellets in the downstream pelletizing process. Now, after this APC control, you can also do the mathematical modeling. So here we do have a OptSim is the product name, which is a mathematical dynamic simulator. It can also do the real values from the plant, and it can correlate, it can calibrate the system based on the mathematical model. You can get the various information from this, like if you want to know the moisture liberation, you can also know the LOI of the system, when it can go out from if you have a high LOI content in your concentrates, then when it can go out, and any reaction in the calcinations, in the reaction in the SOX, you can also do such a mathematical model in your system. That can also combined with the APC, you can correlate both the system in the level 3 automation, and with the combination of the measurement equipment at the site, you can have a full-fledged solution for your beneficiation plant. This is not related to the beneficiation, that also can be extended to the pelletizing plant too. So this is all we are now executing in various plants. If we go to the reference, as I said, we are the SEMI is already in 12 years in Brazilian, and they have given, you can see here in the Ukraine, in Oman, Brazil, and India. As I said, we are going to execute one project in India, and even not only in the pelletizing industry, apart from other industries, cement industry, we do such kind of installations, and we also do for transportation, measurement of such parameters with such measuring advanced smart equipment at site. So now we are talking about the different way of development. So pelletizing, as I said, is the 65 and 70 years or technology already in the market. What new in the market? There are several aspects to develop the pelletizing technology in various aspects. If you see the slides, you can find that we have 6 major areas where we can develop much better to a greener pelletizing plant in terms of energy, in terms of emissions. Now, water is a very much crucial parameter, as we know that water could be a very much determining factor in the coming days. So how to optimize the water consumption? You can increase your availability or operating cost to better maintenance with this very good design of your plant. You can also improve your product quality, as well as you can improve your investment cost with smart plant arrangement, indigenized the supply equipment from India, as I said, to be more Atmanirbhar and make in Indian the supply equipment from India also. So as we see, we have various areas what could be developed in future. We are closely working in this particular area with our universities and with our expert in NUFA team too. Now coming to the reference. So as I said, we are the old wine in the new bottle. But what as a new for what we are now doing, just to brief you through the reference of the new far, we are now presently executing close to 40 million ton of pelletizing plants globally. So if you see in the top, we have Lloyd's Metals, which 2 into 4 million ton plant we are now executing, and also we have different material as input. You can see the magnetite, titanium magnetite as different input material in our pellet plant. And but what well to mention is that we are now executing the pelletizing from 180 square meters suction, the indurating area, to the 648 as of now. But we will definitely extend our great size in the coming days for sure. And if you see in terms of our scope, it can be from the conceptual engineering, it can be basic engineering, it can be the feed engineering, it can be detail engineering of the furnace, it can be detail engineering of the whole pelletizing plant too. If you see the Tebin Bullock project, where we are executing the entire detail engineering of the plant, which is a 648 square meter, having the capacity of 5 million ton. And having said that, we are also not doing only the greenfield projects. We are already executed the projects of capacity enhancement. This is our first project, which is the 2 into 5 million ton plant, where we have extended or we have enhanced the capacity of the plant from 5 million to 7 million ton. So means we are also engaged ourselves in the brownfield project also, where you need to enhance your capacity too. So this is all about the big projects. But as you know, to do a project, we need 3 different aspects. We need to do the customized design. We are not believe at all on the self design. We need to customize based on the input raw material, the chemical constitution of the raw material. So now we are executing several test work in different laboratories globally with our valued customer. And as well as this, there are 3 major objectives to do the pelletizing test work, the pot gate test work we usually say. One is for the new plant, where you have new material, you need to know about the zone distribution, thermal profile, and other things. And the second thing is, if you have the brownfield operating plants, so if you want to enhance your product quality, if you're suffering with CCS, physical parameters, abrasion, tumbler, then how to do the quality improvement. And as well as that, if you need to enhance your productivity, like you want to enhance to 4 to 5 million ton, to 2.5 million ton, then you need to do the test work. So we also do the test work with our partners globally. As you can see, we are now executing total 5 pelletizing, and we have already executed 1 or 2 of them in the test work already. So we are not limited to the green pellet or brownfield projects, not limited to test work. You can see in the next slide where we can extend it our service in terms of the feasibility service, expert service in terms of capacity reduction. We are also doing, as said, the online pellet size measurement. This is the automation project we are also doing in India. We can do some bottleneck study. We can also do some audit, technical due diligence, any kind of support you need for a pelletizing or beneficiaries plan. We are here to support you. You can see that from our engagement from 2019 to 2020 with this slide, where we have engaged ourselves to providing support the industry in various aspects. Now I would like to bring the one topic we are talking about now, the pelletizing industry, and we came to know about the Bali's development, about the briquette. So what will be the future of the sintering? So we know India has mostly 100 million ton of capacity. As we know that blast furnace DRI needs more pellets. So does our pelletizing plant will replace the existing sinter plant? And what will be the future of the sinter plant? Now coming to the situation, the sinter plant, we are now in India mostly dominant on the sintering as a burden, but this, if you want to use or utilize your sinter plant, then you need to, let's say 3 or 4 times your capital, your production, then you need to invest. Can we do so? We are now in such a huge expertise and the fraternity of the iron ore pellet and DRI. Then the question whether we can do something to convert the sinter plant to pelletizing plant in future. So in such a out of the box thinking, if you think, feel free to have any questions, and we are happy to provide you more information and more insight about such kind of development we are thinking, and we have some concept to do, how to do it, and when to do it, and when it can be implemented. So we are all this kind of development. If you feel any kind of questions, clarifications in that regard, please feel free to contact our Indian team as well as our global team. That's all from my side.
Thank you, Soikot. Thank you so much for sharing your valuable inputs. I'll just request you to share your contact details also, so that those in India can get in touch with you.
Yes, for sure.
This is your headquarter contacts. Please share your own contacts also. You can do
Yes.
this in the Q&A section or in the chat section, so that people who wish to get in touch with Dr. Soikot Samunto can do so.
Yeah,
So-
I'll share my contact details in the chat, so that with the email ID you can reach us to us anytime.
Thank you, Soikot. Thank you so much. If you
Thank
stop
you.
sharing the screen, I have something to add before we move on to our next speaker, Mr. Priyaranjan Prasad, Managing Director of BRPL Limited, and again someone who has addressed our conference in Bhubaneswar last couple of months back in February. Mr. Prasad was there addressing our conference, raw material conference in Bhubaneswar. So I'll just take a few minutes from you, Mr. Prasad, before I hand over the floor to you. Now, Ankit, if you could just share our next conference details. We are having our next raw material national conference on technology, market and applications for long products on the 18th of August at Taj Vivanta, Kolkata. And you can see the galaxy of speakers who are addressing us, right from Additional Secretary, Ministry of Steel, Madam Ruchika Govel, to the COO of JSW Steel, Mr. G.S. Rathod, Director Commercial of SAIL, Mr. Chakravarti, the CEO and CTO of Danelli, Mr. Rolando Paolone, Managing Director of Danelli India, Mr. Gajendra Panwar, Managing Director of Arja Steel, Mr. Sridhar Krishnamurthy, Mr. Rahul Enurkar, who is the Managing Director of the Hungarian plant of Liberty Group, Mr. Ashish Anupam, Managing Director, Tata Steel Long Products, Mr. T. Kumaresan, Executive Vice President of Larsen & Toubro, L&T Metal Strategy Group, Mr. Sushim Banerjee, CEO, Iron and Steel Sector, and former Executive Director of SAIL, Madam Radhika Markan, Managing Director of H&K Rolling Mill Engineers, Mr. Deepak Agarwal, Managing Director of Shakambari Ispat, who are also handling Elegant Steel. They are the top brands of TMT in India. Mr. Manish Beriwala, again, someone very close to me, who is the director of Sham Steel Industries. Then we have a couple of analysts, Mr. Jayanto Roy, Senior Vice President and Group Head of Corporate Sector Ratings at ICRA, Indian Credit Rating Agency. Mr. Rajiv Moitra, my brother and partner in Metals and Mining Consulting, leader of Deloitte India. Mr. Manas Mohan Ghosh from Institute for Steel Development and Growth, which is jointly promoted by Ministry of Steel and the steel producers. My friend and my brother, Rajesh Kumar, a country manager who will soon be the managing director of Kalfreeza in India. Mr. Guranchal Singh, associate director of CRISIL, and Mr. Arnab Majumdar, manager management consulting of PricewaterhouseCoopers. So that is the detail of our conference we are having on the 18th of August at Taj Vivanta, Kolkata. And if you could share my contact, so those who are interested in attending our next conference in Kolkata may do so by contacting me with, here is my contact details. My mobile number is also there. You can call me on my mobile. You can send me a mail. You can get in touch with me. And I'm always available to answer any queries that you may have. So those of you who are interested in joining our conference on the 18th of August with the who's who of the entire steel industry may kindly do so by getting in touch with me or my team. And it's on the 18th of August at Taj Vivanta, Kolkata. So that is all from my end. And over to you, Mr. Prasad, to take the floor forward and to talk more on what the pelletization industry needs, what kind of support the pelletization industry needs, and the way forward for Indian pelletization sector. Over to you, Mr. Prasad.
Good evening, Nirmala, and good evening.
Good evening, sir. Warm welcome.
All the panelists and all the attendees. And thanks to Pradipto for asking me to be here. I'll be very brief. I'm already late by 1 hour. Prepared any slides, but I thought of touching upon 3-4 points. First of all, I wanted to speak about slurry pipeline, which is nowadays an integrated part of beneficiation plant and pellet plant. Then I also want to touch upon tailing management. It has been dealt in detail by my previous speakers, so I'll just give my thoughts on that. Then I would also like to talk about a little bit on beneficiation. I will not talk about pellets. Pellets, there are many experts sitting here who've spoken before me and speak after me also. And while talking about beneficiation, it's just not beneficiation of hematite and magnetite. I would also like to touch upon beneficiation of BHQ and BHJ and BH and BMQ and BMJ. That's a very good opportunity that is existing in front of us. And obviously, with any opportunity, there is a challenge. They go hand in hand. And lastly, about logistics, which has not been touched upon by anybody else here. So these are the 4 things that I want to speak about. Now, coming to slurry pipeline, we have 3 slurry pipelines working in the country at the moment. 2 of them belongs to ArcelorMittal and 1 belongs to Brahmi River Pellet Limited. They are long distance pipeline and high pressure pipelines. Obviously, they have high pressure pumps, PD pumps. Very standard pumps that we have. A lot of noise, background noise. Anyway.
Yeah, I would request everyone to kindly keep their microphones muted just mute themselves so that there is no feedback noise. My honest request to everyone to kindly keep yourself muted when Mr. Prasad is speaking so that there is no additional feedback from anyone, please.
So these three pipelines are working right now, and there are 2 or 3 which is being laid right now. One is by JSW, which is about a 30 billion ton pipeline, and one is being laid by JSPL, which I think is about 24-26 billion ton pipeline. And many more to come. Tata Steel is going to do one or two maybe, and there are many pipelines which is on the drawing board and various stages. So this is going to be a big opportunity for the country because it is very, very cost effective, and it's a green technology. Only thing is it needs a lot of challenges. Recently we had a conference organized by Osenco on the pipeline technology, and a lot of people attended. Most of you must have attended that. And it needs a high amount of discipline in operations, because the pipeline needs very disciplined practices and operations. And as I said, any opportunity is linked to a challenge. The challenge is to get the clearances, permissions. Water is a big challenge because it is the river waterway which is being used to pump, and the challenge is to recycle that water, when it reaches its destination, which is more than often not thought through. There are cases in which it is proposed to bring the water back, but then it needs that much more cost. So the challenge is that. Luckily for us in Brahmani River, we had a lot of industries around, Tata Steel, Kalinganagar being one of them. And we took the government's permission and put a pipeline from our plant in Jajpur to the Tata Steel Kalinganagar plant, where the water, after being separated from the filter, is treated, cleaned, and then pumped to Tata Steel and to the IDCO network. So that is one challenge which is always there with the pipeline. Pipeline needs two things. One is discipline of installation. It has to be installed exactly as per the recommendation, and it must be operated upon as per the recommendation. And I'm mentioning the 150 micron particles should be as low as possible. It be less than 1% or 0 if possible. That is about pipeline. The second thing that I want to touch upon was tailing management. Very few people have tailing dams. Of course, those who do the ore processing in the mines, they have their own slime dams. The people who are processing the ore or beneficiating outside the mining lease area, they have to have a tailing dam. And even if you have the tailing dam, what do you do with the tail that you have put inside? There is no value for it. And has to come up with, or all of us have to come up with some solution for that. We don't have solution at the moment. The government has set up some committees to look into that. One obvious solution is that you pump the tail back into the pit that has been mining pit that has been exhausted. But then there are various challenges in that. The Act says that you can take out ore from mine one location to the other location for which permits are issued, but you cannot bring anything from outside inside the mines. So that needs a relook on the part of the government together with us, and we need to solve that. Also, since at the moment cutoff period point is 45%. Less than 45, there is no use of 45% Fe. There is no use in any industry. Going forward, it could be even below. So we got to be prepared for that. Talking of beneficiation, there has been some pictures shown that there are huge dumps lying in the various mines. One estimate is 130 million ton. It could be more than that. I remember one of my senior colleague, Mr. CM Purohit, saying that it is not a high grade ore or a medium grade or a low grade. Ore is ore. It is we who have created a high grade or a low grade or a medium grade. Ore is ore that is available in the market. Available in the entire thing has to be treated so well that we make it 60. So it is in that context that all of us have the responsibility to blend and or use and beneficiate so that the industry, the steel industry, meets its requirement. The next stage is the huge deposit of BHQ and BHJ and BMQ and BMJ, which has not been assessed so far. Some beginning is being made. JSW is one of the leading companies into beneficiation. They do a very good amount of beneficiation in their plants in Karnataka near Bellary. And they are also into doing research work for BHQ, banded hematite quartzite. And I'm sure if we all put our efforts in the right direction, we'll have a technology. In China, they do it. Of course, the yields will be lower, but the advantage is that BHQ and BHJ, they don't have alumina. They are only silica and hematite or magnetite. We also, along with Dr. Biswal, I think he's there in as one of the attendees today. We, along with Dr. Biswal and IMT, and also with IBM, have tried to explore that possibility. And I'm very hopeful that in the next 3-4 years' time, we will have a plant in which we will beneficiate, upgrade BHQ and BHJ for making pellets or pumping into the slurry pipeline. So that's a big opportunity for the entire nation. Of course, very challenging, as your topic says, challenges and opportunities. It's very challenging, but going forward, we need to do that. And as a country, we must do that. The last topic that I want to touch upon was on logistics. It is very, very difficult and very organized in a I would say in a negative form rather than in a positive form. Very expensive to transport. There have been a lot of improvements. Government has made good infrastructure for the movement, but a long way to go. Like in Australia, one rake, you transport almost 30 to 40,000 tons. Whereas we do only 4,000 tons in a rake, and road transportation also is very organized in a different manner. There was a time when we could use only, at least in this part of the country, which I'm talking of in Odisha, there was a time when you could only use Tata diesel vehicle 6-wheelers, is 10-tonner. From there, we have come to stage that we can use 40-tonner and 45-tonner. So both the industry and government and also the association are working hand in hand but there is a long way to go there also. Thank you very much. These are some of the thoughts that I had. I have not touched pellet, but there are a lot of very good speakers before me and one sitting just after me. So they can talk about pellets much more than. But these are some of the points that are very important for the pellet industry to grow. Thank you very much.
Thank you, Mr. Prasad. Thank you so much. And one thing which is always said about Mr. Prasad is he's a wonderful human being. So besides being a pellet producer and head of a managing director of a pellet producing unit, the first thing which is mentioned about Mr. Prasad is a wonderful human being. So
Thank you so much.
That is something which all of us should know here on this platform, that there was someone today who, besides being an expert on a pellet plant, is also a good human being who shared his thoughts with us. Now, the entire world, most of the people I have come across is mostly, are good people, but there are a few, I would say, who have a different perspective. Yeah.
Who are extremely good.
The point which I was trying to make was, you mentioned about the slurry pipeline. Now, one of the challenges is the security of a slurry pipeline. So that is what I meant when the Naxalites, they attacked the slurry pipelines and cut it off. One of the challenges which the slurry pipelines have to ensure is the security. It has to be built along the national highways or wherever protection is available. So that is a big challenge for the slurry pipeline. One. Number two, you also mentioned about my mentor and a person whom I have a lot of regard for, Mr. C.M. Purohit. And I'm surprised to see that even beyond 7 o'clock, Mr. Purohit is still there as an audience today and listening to us. And Mr. Purohit has been someone whom I have always sought guidance from. And I'm happy that you referred to him today. So with that, Mr. Prasad, once again, my thanks from the bottom of my heart. And I look forward to your presence in future conferences that we do. In fact, there is a lot I have thought of in Odisha, primarily taking the beneficiation, pelletization, and I would say proper judicious use of our natural resources. That's what I refer to when I talk about using the mineral resources judiciously and intelligently. I think Mr. Sahu will also agree with me.
Yeah, thank you, sir. Sir, I will just add for 1 minute.
Yes, sir, please go ahead.
Regarding that slurry pipeline, yes, I agree, threat is there by the miscreants. Because that SR steel plant who have laid the slurry pipeline from our Kirandul project to Visakhapatnam, stretching for a distance of around 420 kilometers. That is working now also, but they have laid it over the ground. And yes, you are very correct. I agree. That has been destroyed by Naxals or some miscreants, maybe during last 20 years, more than 50-60 times, more than that. So even then they are managing. But considering that experience, we in NMDC, we have also planned to lay this slurry pipeline from Kirandul to Jagdalpur steel plant, stretching for a distance of 130 kilometers. But now, by taking that experience, we have planned in such a way that our pipe will be beneath the ground, below the ground, at least 2 meters everywhere. So that we have taken up as a safety precaution, considering the past experience. This is for information of the whole house.
I think one more thing, Mr. Sahu, the NMDC pipeline will be mostly along the national highways, if I'm not mistaken.
Yes. It is by leaving 50 meters from the edge of the national highway.
Right. And I think the other topic which Mr. Prasad also touched was logistics, which is a very important issue. Whenever we talk about the steel industry, we always say that for every ton of steel, you need 4 tons of logistics to be
Raw
handled.
materials, raw material logistics.
Yeah, 1.6 iron ore, then you have coal, you have fluxes, you have the finished material. So altogether, it is 1:4. So that way, the logistic plays a and these days logistics have become more and more expensive. I think the government should think of using the waterways. And iron ore, one thing which is said about iron ore is iron ore becomes affordable only because it is mostly seaborne. So we have to look at ways and means to use more of our waterways and make our rivers more navigable, so that we could use the waterways to bring down our logistics costs. That's one of my thoughts, which I thought I'll share with you.
Yes,
Okay.
correct.
Sausab, with your kind permission, I'll move on to the next two speakers.
Sure. Thank you.
Two speakers from two of the largest producers.
So how many speakers left, sir, now by this time?
By this time, we have Indrajit Paul from Tata Steel, Mr. Naveen Lobo from JSW Steel, and Mr. Haibal from Primetals, followed by Anil Bhattacharya. So 1, 2, 3, 4. 4 and 2 back-to-back from Tata Steel and JSW. Tata Steel, Mr. Indrajit Paul, Chief of Pellet Plant, Tata Steel, and Naveen Lobo, General Manager, Process Control, Iron Zone, JSW Steel. So over to you, Mr. Paul and Mr. Lobo, back-to-back. I will not get in between. Back-to-back, once you finish, Mr. Lobo can start. Over to you, Mr. Paul.
Thank you. Very good evening to all of you. Hope I am audible and also my slides are visible.
Absolutely audible, loud and clear.
Thank you so much. So good evening, a very good evening to all of you, the Steel and Metallurgy team led by Nirmal and Ankit, and to this August gathering, and on a very special and important topic of challenges and opportunities in the iron ore, DRI, and the pelletization in India. It's definitely a privilege to speak in this platform and giving you a perspective, and in fact a different perspective, because we have all talked about pelletizations, and in many of the forums, also in steel and metallurgy, I speak about pelletization. But this time I choose to talk about a topic which normally eludes us. So are we Industry 4.0 enabled? So I will try to provide some glimpses of Industry 4.0 digital transformations at Tata Steel, and especially in pelletization. Because going ahead, definitely this is a topic that we all have to embark upon. And as a whole in agglomeration process, through remote operations, the controls, and thereby achieving a business agility and talent mobility. Did my page change? Please confirm.
Yeah. You can go ahead.
Okay, thank you. So, as a Tata Steel on a connected platform, Tata Steel being integrated steel plant, and we are roughly on more than 100 years with annual production of roughly 20 million ton capacity, and spanning from mining operations, iron making, steel making, downstream processes, marketing and sales, and extending to customers' doorsteps with our products and solutions. And as Mr. Nirmal was talking about the achievement correction, 1 ton of hot metal roughly in the blast furnace needs roughly 4.5 to 5 tons of charged material. Therefore, logistics, as Mr. PRP was talking about, is very, very important. And so there is an urgent need to make the process energy efficient, logistically efficient, economically viable, and definitely economically sustainable. To have this idea into being, so we thought of a digital transformation phases. And this digital transformation is an ongoing process. It's not a single day activity. So it is a phase-wise manner in which you have to go. And you have to believe it. The fundamental belief system also got established somewhere in 2015 and 2017. And as the belief system got established, there was an acceleration strategy which spanning through 2018 to 2021. And therefore the deployment in the best in the class initiative we started sometime in 2022 and beyond. So if I talk of the journey, so we talk of, just a moment. So we talk of the remote operations. So in digital transformation journey, So we started very minorly with the train radio remote operations. So once we got established into it, it is very important to show you the journey because it didn't happen in a single day. And before we catch on the processes, it's very important to establish the concept. And fundamentally, it is very important because these are very big capital incentive projects and process, and therefore it is very important to establish this concept. Later on, we also initiated the hot metal carrying locomotives, and we initiated through radio remotes. Then the LD control rooms were covered with the video walls. Normally, we all know that we see our plant and then operate, but we initiated the concept that can the operator see through video wall and be separate from the LD converters or from the process called blast furnaces, sinter plant or pellet plant, and see from a distance. Then we started the era of the manless crane operations that got initiated. Fundamentally, once all these things got initiated, we took the audacious decision of can a plant be operated from a remote corner? And in 2022, that is just last year, two of the most important processes of iron making, that is the sinter plant and the pellet plant, that got commissioned. The remote operation control room got commissioned. And as of now, these two plants are being operated from a distance of 7 to 7.5 kilometers from the actual plant site conditions. So this was a very audacious task and the audacious decision that we have taken. And to tell you frankly, this particular thing is running from last 1.5 years and is exactly established that it is not necessary for the integrated steel plant control room to be just beside the plant itself. So this is proven from this particular initiative of ours. So what are the enablers? So the enablers are basically the imaging and the sensing, and fundamentally breaking the virtual barriers. We also have established digital twinning with respect to the processes and the assets that we have. We consider remote operations of our capital equipments, and fundamentally the testing part. So most of the testing has now moved from the laboratory to the online testing and finally the control. So this you already know. So we span from raw material to marketing and sales, and we are trying to integrate this digital transformation in each and every field of it, so that as a group we become Industry 4.0. As a team, we march towards that particular area. Some of the examples, although these are very few, but it's very important for you to understand how did you do it. So first is basically the remote operation of the locomotives. Definitely, it improves the safety. It also improves the productivity of it, and fundamentally also the locomotives availability improved. As I told you, that video wall concept of observing the process. So initially, the blast furnaces, the sinter plant, the pellet plant, the coke ovens were just beside, the controls were just beside the shop floor. But as of now, through very high quality cameras, we have moved from this actual displays to a video display to video walls, and also it improved the safety. The cranes, so we have moved from manually operated cranes to manless cranes, which definitely, believe me, it improves the safety, the ergonomics, the productivity, and also that it is easy in operations. All these things also got enabled with soft sensorization, because the soft sensors are very important and is deployed where the direct measurement is not possible, because in every places you can't have your thermocouples, your flow meters, and everything. The high temperature, because the entire process is related to high temperatures, there are a lot of dust, which is basically very corrosive, and also it influences the electronics of the measuring equipments. That is corroding the system, and all these things make the instruments and the measurement very, very difficult and also erroneous. So therefore, this soft sensorization has provided reliability, also has improved the repeatability of the things, the self-maintainability, adaptability to it, and also is cost effective. So this soft sensor is not related to a single process, because as you are trying to enable us in the entire process into Industry 4.0, it is important each and every processes should have this application of soft sensors. Let it be the hot metal or slag generation rates, let it be the flow rates of as hot a metal or a fluid like the hot metal and slag itself. Because I'm not talking about water flow measurement or gas flow measurement, which all of us know. But now we are talking about, can the hot metal flow rate be measured? Can the slag flow rate be measured? And therefore, all these soft sensorization are towards that. Can the torpedo, which is totally inside line with with refractory and it is not visible, can we think of a wear profile of the torpedoes? Can the hurt, which is only visible after 20 years in the blast furnaces, can this soft sensorization, we can predict the hurt wear? So these are some of the initiatives that we have taken all through across the value chain to understand and to improve upon the soft sensorization, finally leading to digital tuning and also the process control enabling the digital 4.0. So all these things have been, some of the other examples are related to our area of operations is the in sintering and pelletizing is size. We talked about the size measurement because it is very important for both the sinter and the pellets to get size measured, and we produce in tons and tons and thousands and tons. And if you take the samples to the lab and get it measured, and by the time it reaches to the analysis floor, the material is consumed in the blast furnaces. What's the use of it? So therefore, this online sensors help us to have an online not only measurement but also control. The entire fleet of pellet cars, both in the sintering and pelletizing, it is very tedious to maintain those because you have to monitor it. And is it possible for a single man or a small team of persons standing on beside the shop floor, observing each and every nuts and bolts of that machine? Not possible, and definitely we will miss some of the important statistics. So therefore, we have also devised a pallet car management technology where each and every parts of the pellet car are being seen through soft sensorization and through cameras. And through that, we are doing interpretation about the present condition of the pellet cars. The tours, which is definitely a very difficult place to visit and a hazardous place. Initially, we used to have people monitoring it. Now we don't have. We have the online cameras of all the tours in the blast furnaces, and they give us a visibility and about what the injection rates that all are going. We know in both in sintering and pelletization, fundamentally is the bed flatness control. It has to be a flat bed to have a better permeability. And this particular things, we try to first measure and then control. Then the coke plants, many of the flue gases are getting measured. And fundamentally, the aspect in which we are talking about is that of this monitoring and measurement system has improved the ergonomics and also human safety, better process control, improved visibility, faster and continuous data acquisition, and all this sensorization, all this data are moving into the digital twin, which is giving a lot more visibility and control on the process. And all these inputs and finally led into the digital twins. So we have digital twins operating for the sinter plants. We have digital twins operating for our pellet plants. And the entire system, like from supplier, the input, the process, the output, the customers, and the byproduct and the environment impact for the stack emissions and all. We through digital twin in sinter plant, we are claiming that the sinter plant stack emissions are in much better control than before. The quality and the quantity inputs definitely they vary. The process also varies based on the inputs also variation. So it is not possible for a human being to understand each variation and take process control. The process safety, which is as of now is coming on the very important subject of process control. That also is coming up in a digital twin process. The equipment failures, the abnormalities, the breakdowns, and all these things are a part of the very high visibility, and therefore we improve the maintainability of the plant. This digital twin provides an integrated platform to strategize, to plan, to simulate, and to train. It also have an opportunity to train your operators because you can simulate. You can simulate a particular pattern. You can simulate a particular scenario and see how the process will behave. And definitely it gives a much better control platform than a manual control. So these are some of the glimpses of the digital twins that we have tried to create in coke plants, in pellet plants, in the plants. And based on these, we are also trying to replicate our blast furnaces in digital twins and also the continuous casters. So the effort is on to integrate the entire process into a digital twin so that the entire process can be visualized altogether in a different platform. the connected operations, that is remote command center. So all the above inputs that I have talked about, the right from the remote operations, the video wall, the video analytics, the soft sensorization, the image processing, the special sensing techniques, the digital twinning. Now the stage was set for the remote operations through a virtual, not the actual command centers. And we divide the concept of from the near side, what I talked about to you, to a far side operations. Can we move beyond the control rooms, which is just at the vicinity of the plant? We have much safer, much better, much cooler, much safe places to control. And that's how started. Sorry, that's how we started with respect to these remote operations. These virtual command centers are fully technology enabled with real-time data feed, the voice, the videos, and the data overlay. So the fault tolerance architecture is also devised onto it. We have that clustering with the cloud leverages, and added with it is the digital twin and the ANI that is there over there. Operationally, these virtual offsite command centers provide unique opportunities for agile decision making, because we are finding the synergy, collaboration, and cross learning is really improving through this. The talent mobility, because we are finding that agnostic the asset locations and the talent development is improving. And the new concept of work from anywhere, because after COVID, these are concepts that have come up, that work from home and work from anywhere. So therefore, can the control room work from anywhere? So that concept also helped us to think in this particular line. So at the last, I conclude that in Industry 4.0 is the requirement of the day, which helps you to efficiently run the process. Because efficiency not only in energy, not only in throughput, not only in quality, but overall, and also in productivity, and in a complete industrial perspective. So we are looking forward to Industry 5.0, but definitely we have to, because sustainability across the value chain is an important equation. Therefore, we have to take into consideration right from Industry 4.0 to move to Industry 5.0. Sustainability doesn't mean only in terms of green, but this means sustainable coexistence of the human and definitely with the technology. From this perspective, few important points that which emerged from our experiences, the users, the work from anywhere concept, the remote operation that we talked about, the responsible AI, the assistive technologies, the ease of business processes and models are resilient enough. And we are slowly taking steps, and Tata is slowly taking the steps towards that vision of us, of Industry 5.0 in future. All these are especially important in Indian demography and also in industries across the value chain. So today it is not seamless. The transition definitely is not easy, and we have seen it happening, because this physical workplace and the virtual workplace, especially in our industry of the steel industry, it doesn't happen in a single day. It possesses a very additional risk how effectively you can use this mobile device as a shop floor. And believe me, we at Tata Steel are trying hard to it, and to a great extent we have been successful in doing it. Thank you for listening, viewers. Thank you all.
Thank you, Mr. Paul. Hope you can hear me.
Yeah.
Well, thank you so much, but without wasting any of your time, those of you who are interested can connect with Mr. Paul directly. His mobile number and his email address is given on your screen. So those of you who have any questions can ask him directly. Without wasting any further time, over to Mr. Lobo, and the floor is all yours, Mr. Lobo. Mr. Naveen Lobo is the General Manager, Process Control Iron Zone at JSW Steel. You are based in Bellary, if I'm not mistaken, Mr. Lobo?
No, sir, I'm in Dolvi right now.
Oh, you are in from Dolvi. Great. So over to you, Mr. Lobo. The floor is yours. By the way, as you already saw, JSW is the largest producer of pellets in the country today.
Yes.
So over to the largest producer of pellets.
Hello. Yeah.
You just, Mr. Lobo, you just need to maximize your screen in full screen mode. Just
I think it's already done, no?
No, it's not on full screen. You have to just click at the right hand bottom and make it full screen right up. That's all.
Okay, before that, when the full screen is coming on, I'm just drawing it. I think warm greetings of the day, wherever you are, anywhere in the globe. I think we have participants from different parts, so warm greetings of the day. So we have traveled along this, what you call, long time from wherever we started the beginning of the session of this webinar, with an overview of the steel industry, the requirements, from the pelletization, the beneficiation, the mining, various aspects. I think now it's time for us to go to the hardcore where the actual operations of the pellet plant happen. So I'm going to touch upon the few challenges at Dolvi, what we faced, and what are the opportunities we used to grow. I think now it is the full screen.
Not yet.
I think here I'm getting its full screen, but are we able to move down the slides now? Okay.
Yeah. I think if you click on the slideshow, you can make it.
Okay, fine. Yeah, this is how we are going
on the top bar. If you go to slideshow option, if you just click on slideshow,
yeah,
on the top, 1, 2, 3, next to animations is slideshow. Next to animations on your top. Yeah. From beginning, yes. And then full. Okay. Start slideshow. View. I think view full screen of. It should ideally be view full screen.
Yeah.
What happens when you click at the bottom right? Just share the screen once again. And is your file open?
Yes.
Yeah, now it's fine. Yeah, there you are. There you are. Now you are fine. Now you're ready to go. Perfect. Now you're fine. Absolutely fine.
But I think the slides are not moving. Are you getting the next slide?
You're back to the first one, but we went to the next slide. Yeah. Yeah, there you are with the second slide. Yes, we are moving. You are moving. absolutely fine. You need to start sharing again. It was going fine. It was going fine.
No, I was not getting the slides moving on my screen.
Okay. Can you try sharing again?
Yeah, that's what we're doing.
You have to open the presentation first, then share. First, you'll have to open the presentation. You click and open the presentation and then share it. Then it's going to be fine. First, you can open the presentation and then share it.
Standard display.
Yeah, maybe you can close the presentation and open again. That will be easier. You can close the presentation and try opening again. Andrin, any suggestions? Where could have, yeah. Yeah, that's fine. Now you can, yeah. Now you can just go to full screen.
Are you getting me now?
Yeah, but it's not anyway. This should be okay.
Okay, I think we'll move ahead. I don't know. There's some hiccup on this. Okay. Okay, this is what we were thinking of. That this is a what you call JSW presence in India as well as globally. And as you have just said that we are the country's largest pellet makers, almost 34,000 and 34 million tons per annum. And we are located at Dolvi. And for those, Dolvi is present at western part of Maharashtra. And this is how we are operating, basically the 10 million ton plant now, where we have 2 coke oven plants, 2 sinter plants, 2 pellet plants. Then we have 2 blast furnaces. In fact, country's largest blast furnace is also here. Then we have a sinter plant, SIP at Dolvi, as well as one at Salav. Then our downstream steel making units will be having a Konak steel making facility and the BOF facilities, and the thin slab caster, as well as the billet caster, as well as the hot strip mill. And our product portfolio is we have flats as well as longs at Dolvi. So this is basically that I'll skip it very quickly. And now let us come to the pellet plants operations. This is the 2 pellet plants what we are having at Dolvi. The pellet plant 1, which came up in 2014, is a Metso supply mill machine, And the pellet plant 2, which came up in 2021, is an 8 million ton Autotech supply. The uniqueness of these plants is the pellet plant 1 is a high bed operation of 550 mm, and the pellet plant 2 is basically a 400 mm low bed operation. Another uniqueness is the wet grinding systems what we have at Dolvi. Pellet plant 1 is having overflow type mill, whereas pellet plant 2 to cater to the soft ore is having a great discharge. In the pelletizing discs, pellet plant 1 is normal discs, but pellet plant 2 we are having single deck roller screening where we screen the oversize and the undersize at the first phase, and then we have a unique facility called the bilayering or the segregation, where your smaller size pellets are fed onto the green pellet or the indurating pellets at the lower layer, and then the oversize at the upper end. We can grind hard ore in pellet plant 1, whereas soft ore in pellet plant 2. Another uniqueness of pellet plant 2 is this is designed for flux pellets or the higher basicity pellets. That's what we were thinking about. The quality parameters what we would like to maintain at pellet plant 2, the pellet CAO at pellet plant 1 is from 1.4 to 1.6, whereas in pellet plant 2, as I was telling you, it is high basic pellets or high flux pellets in the range of 2.5 to 3, and MGO in the range of 1.0 to 1.8. Remaining properties almost remain the same at both the plants. At pellet plant 2, we had envisaged or we were doing olivine grinding also along with the flux grinding so that we have higher MGO in the pellets. Coming to our customers, our customer for pellet plant 1 is blast furnace 1 and the sponge iron plant at Salav as well as at Dolvi, and for pellet plant 2, we have the customer in the name of form of blast furnace 1 and blast furnace 2. The grade of pellets what is required from pellet plant 1 is DRI grade pellets, Fe being more than 63, and the CCS above 280 and tumbler index above 94, with RDI below 9 and RI above 70. And for blast furnace 2, the requirement was, as I was telling you, we require higher flux or higher CAO pellets, 2.5 to 3%, and MGO from 1.1 to 1.8. Now let us come to the challenges what we have that we had at pellet plant. So being a high pellet operation plant, I think when we were discussing, Mr. Bhatnagar was telling that plants operate at around 35% pellet. But at JSW, we are operating above 60% pellets. In fact, we have gone up to 70% pellet operation also. So to meet that and to meet the control of slag basicity in blast furnace, we required a basicity to be above 0.8 also. But owing to the high silica in the ore, chasing 0.8 basicity was always a challenge. To overcome this, what we did was we optimized the CAO and MGO percentage in pellets. So we tried to maintain, we slowly went up from 1.8 CAO up to 3% of CAO in pellet, and MGO also from 1.8, 1.1 to almost 1.8 we went, and we made it to the, found out that the optimization of CAO around 2.8 and MGO of 1.2 was very suitable for a blast furnace operation. And the bottom slide or the scale will be telling us that for BF2 feed mix of 67% pellet and 33% sinter, 1.8 CAO initially was needing 62 kg of limestone charging at the blast furnace. It was reduced to 31 kg when we went to 2.8 pellet CAO in pellet. That means almost 50% reduction in the flux addition, which resulted in fuel rate at BF going down by almost 5 kg. So this challenge is what I think many plants would be liking to do. Another challenge what we had was a higher pellet fines generation at the BFN. Initially, when we started pellet plant 2, we were trying to maintain a size range of around 12.5 plus minus 0.2. But with the higher CAO what was required for the pellets, it resulted in a lower tumbler and higher abrasion, generating more fines at BFN. It was almost more than 10-12%, which was a nuisance there. So to overcome this, one innovation what we did was we reduced the pellet size to 11.5 mm. And the result was really encouraging. The tumbler, which was hovering around 92 to 92.5, went up from 93.5 to 94 with a regression of 0.64, resulting in the blast furnace size reduction, what you call fines reduction to below 8%. Another unique challenge was we had varying iron ore sources which had high fluctuations of silica, alumina, and alloy. Initially, we were planning to feed Orissa as well as NMDC fines, but owing to the shortage of these ores, we had to use imported pellet feed as well as indigenous sources from Surjagarh and Jabalpur. A typical case was of Surjagarh fines, where the chemistry was, very similar to that of Bacheli or NMDC, which was very suitable to us, but we had problems in the plant. So the analysis part, we can see that it was very near to Bacheli, but we found out was we were having problems in our filtration, we were having problems in our balling, and then we had problems in the induration cycle also. When we did analysis of this at our Vijayanagar plant with the different combinations, we found out that Surjagarh was, a little bit of having more gypsite and kaolinite, which was making the material stick to the filter cloth, and the output was less, as well as it was having a sticking tendency in the pelletizing discs. So with the certain combinations of different ores and with these tests, we optimized the use of the Surjagarh fine to 15% to 20% of the feed mix without affecting the quality and quantity. So this was one of the challenges what we overcame to use Surjagarh. Another challenge what we faced was the usage of in-house fines in our plant. Because of the higher volumes of dust generated, because of the blast furnaces as well as the steel making shops of a higher capacity, we were having, and sinter plant was having a limited capacity to use this dust. So pellet plants were forced to use these dust, and we can see that right now we are using almost 75% of the in-house dust that is generated, and only 25% is given to sinter plant. So for this, what we did was the segregation of the carbonaceous and non-carbonaceous material to be fed in ball mills and the mixer circuits separately. And we developed 3 additional conveying systems at the ball mill to feed this material, one at the and other at the mixer. So overall now, right now, both pellet plants put together use almost 75% of the in-house dust that is generated. Moving to the opportunities, what we have utilized, what we were given with. First is the digitalization thing, where we have, I think Newfer also was speaking about it. We are in an advanced stage of usage of advanced process control at pellet plant 1. We have 3 models over here, one for mixing and the balling. We have one for indurating machine and one for the integration of these 2. As you can see, the challenges were the manual intervention of the balling disc operator was more, but because of this technology or APC what we have used, now we have reduced the intervention, we have increased the productivity. More so now, the second module of the indurating machine is in place. The BTT, that is the burn through temperature, driving the total process of it, and then control, giving it the integration to the pelletizing discs to give a stabilized feed and stabilized furnace operation. This is where we have installed the APC system in the pelletizing disc. The other opportunities what we have utilized is because of our in-house usage of carbonaceous material. Our present GCal is somewhere around 0.18 to 0.2 compared to the universal norm of 0.2 to 0.25. We have used the flexibilities at pellet plant 1 as well as pellet plant 2 mills to use different sources of iron ore, optimizing the parameters of process in the grinding circuit. Another thing what we have looked into and the opportunity we have taken is interconnectivity of both the plants to sustain the productivities or the production levels, interchanging or feeding slurry from pellet plant 1 to pellet plant 2, or transferring ground fluxes from pellet plant 2 to pellet plant 1. One more problem what we were facing because of the increased silica in the ore was olivine also, which we were using to increase the MgO content in the pellet. We were increasing the silica also. Now what we have done is we have gone to the indigenous supply of dolomite more, so and reducing the olivine percentage so that silica is diluted in the pellets from 6.2 to 5 to 5.4. We have this low bed operation, as I was telling you, in pellet plant 2 and the bilayering, which is helping us in processing of low grade iron ore fines. In future, what we are planning is a centralized system for uniform slurry transport from pellet plant 1 to pellet plant 2, so that the variation in chemistry can be overcome. So this is in brief. I have hurried through the presentation. So we will be available for any queries regarding the operational part of this. Thank you.
Thank you, Mr. Lobo. Thank you once again for a very detailed presentation on the pelletization plant of JSW. Once again, you're not just the largest, but you invested heavily in pelletization, and using our resources judiciously is what Mr. Sajan Jindal always talks about. And, let me place this on record on a public platform today. Yeah. Am I audible? Yeah. Okay. Yeah. So what I wanted to mention was Mr. Sajan Jindal is the most visionary steelmaker that you have in this country today. I have not seen anyone who's as aggressive as Mr. Sajan Jindal when it comes to expansion. In fact, one of the stories which goes is, the earlier CFO, Mr. Sheshagiri Rao, was at times skeptical about expanding so fast. But I think Mr. Sajan Jindal always kept on saying that he told me once in an interview to me that our DNA is very aggressive. Mr. Sajan Jindal told me that we have a very aggressive DNA. So that is what keeps Mr. Sajan Jindal way ahead of the other steelmakers in this country. So my salute to Mr. Sajan Jindal for what he has done for this country.
Absolutely true, sir. Absolutely true. And that's what is driving.
I would always say hats off to Sajan ji for his risk-taking abilities, for what he has done for this country. A tremendous achievement with Sajan. Even during the peak of the pandemic, Sajan ji drove from Mumbai to Bellary all the way, 14 hours non-stop drive. Which other industrialist in this country do you think would do that? So, the immense respect I have for Sajan ji is because of what he has done for this country. So with that, I'll move on to our next speaker, Mr. Bernard Hebel, Head of Technology and Innovation for Agglomeration and Direct Reduction at Primetals Technologies. So over to you, Mr. Hebel, and Mr. Lobo, if you could just stop sharing your screen so that Mr. Lobo could start sharing his screen. Over to you, Mr. Lobo, Mr. Hebel.
So,
Mr. Hebel, yeah, once again,
okay.
Guten Abend, and let's hope Primetals, which has been well known in India in the previous form of Siemens VAI and earlier as VAI, is still, a pioneer when it comes to pelletizing technology. And the circular, the two biggest products which I have always written about in Primetals, one was, I had a friend called Christian Christian Baum,
Yes.
who was the head of Corex, and the other is Primetals Technology. So two product lines which I have written the most about is pelletizing plants, circular pelletizing plants from Primetals and the Corex. These are the two products which I have written the most about. So over to you, Mr. Hebel, and you are also in Linz, right?
Yes, I'm in Linz. So thank you very much for your words.
I have spent a lot of time. I've spent a lot of time at Linz. Going from one building to the underground and moving on to the next building. I have moved in around your office several times, and also spending time at downtown Linz for quite a while.
Okay, thank you very much. Can you see my screen?
Yes, of course. Please go ahead.
It's a big honor for me, to speak to you a little bit. Thank you for the invitation. We do not only Corex and CPT. We do several things. I think there is no need to introduce my company. We come out from First Alpine Industrieanlagenbau. We were the inventors of the BOF, so the LD converter. I also heard about that one of the first pellet plants in India, Mandovi plant, 1.8 million tons in the 70s we built. Now we are 100% daughter of Mitsubishi Corporation, and we are a full liner from beneficiation to strip processing. And we have this Kolkata office with around about 500 employees. So I'd like to speak a little bit more overall what we are doing, how we are seeing the future. What we are talking about transformation, and what we see. India is completely different to Europe nowadays. We see a lot of big blast furnaces, still increasing blast furnace capacity in India. But I think the transformation will be more complicated than some guys thinking about. It's not only changing to pellets, direct reduction, maybe with hydrogen, because as mentioned several times today, the hydrogen costs will be high in the next 10, 20 years. And there will be some other problems what we are facing, because in principle, we are talking about electrification. This is our portfolio. We are a full line, and also, of course, in steel making, we are offering a lot of different routes, from the coal-based route over our Corex plant, Phoenix plant, Corex plant in India. It's a compound with a Corex and Mitrex plant even. Then we are Mitrex licensee on the R plants. And then we have our, it's unique for us, our both fluidized bed-based technologies, but this will come later on. But because in principle, what we see is Sorry?
I would request everyone to kindly mute themselves because otherwise we can't hear what Mr. Bernard Hebel is mentioning about. We can't hear him at all. please mute yourselves so that we can hear him.
Okay, thank you. The most important thing when we're talking about the transformation to DRI from blast furnace is the basis of the iron ores, which are processed now in the blast furnace and cannot be processed in a DR plant in an electric arc furnace. With 62-64% of Fe grade, the slag rate will be too high. So we will have in the future this electric smelter. This electric smelter, which in principle makes the hot metal. So we will see direct reduction of pellets, even of sinter, in our opinion. Then having this electric smelter, and then the LD converter as in the past. Just a comparison, and please don't nail me on the values exactly, but starting from blast furnace, we have 2 tons of CO2 per ton of liquid steel. In future, maybe precondition that we have only a small footprint of CO2 on electric energy.
Bernard, just sorry to interrupt, but your slides are not moving.
They are not moving. Oh, sorry. How does it work in Zoom? Just
yeah, now it's fine.
now you can see it?
Now we can see, yes, of course.
You can see the smelter.
I can see the smelter processing of low-grade DRI. Yes, we can see
Okay.
this.
So yeah, but I will not come back now. I mean, so the next one, yeah, just the figures as a short comparison. And this is preconditioned that the electric power is green. Yeah, in principle, green, only 80 grams CO2 per kilowatt hour. Then we have, of course, near zero with a DR EAF. And with a smelter BOF, we will be higher because we will need this carbon, more carbon in the smelter. And with natural gas-based direct reduction, we will more 0.5, 0.6 tons more. So round about 1 ton of CO2 per ton of liquid steel compared to the blast furnace of 2 tons. So, but now what does this mean? For example, for pelletizing, everybody's talking about increasing direct reduction capacities in the future and therefore pelletizing capacities. I mean, it's not a big calculation. If we want to be zero in 2050 or 2060, or maybe 2070, we will have electrification. We will need pellets for direct reduction. In our opinion, as mentioned before, we are also looking on how to process sinter in the direct reduction because the sinter plant has its advantages. So a big capacity increase of pellets will be needed. It was mentioned several times today, but it's also our opinion. I mean, this hydrogen story, nobody knows how it will work. There will be a lot of electric energy needed. And yeah, let's see. This is a slide not from my side. It's from Mr. Poveromo. I think everybody knows him because there are some questions. We will have increased pellet capacity needed, but can we replace completely the sinter? Is it sensible to do this? And will we have the concentrate for the pellets? And what we are sure and what we see, we will not have classical DRI concentrate available to substitute blast furnace, maybe 100 million tons more, maybe 150 million tons more, because but it was mentioned today several times, there will be concentrate, it will be upgraded better and better, but at the end, it will be a concentrate like producing blast furnace pellets, which will be then directly used in a shaft furnace, for example, in a Midrex furnace, and then processed over a smelter and a LD converter. So the challenges in India are, of course, special. We have, I think I can go through because we have heard this several times. We have 200 million tons targets, 300 million tons of iron ore processed. We have still 33% of lump, round about 66% of fines. We have heterogeneous ores depending also on the places, on the mines. We have discretite ores with high LOI, with high alumina and silica contents. And this is sure that it has to be worked with. So the actual situation is the consuming in future also this low medium grade ore is unavoidable for Indian steel production. I mean, what we see in the last times, and we heard it also today, the pellet producers become better and better. The pellet quality based on this iron ore in the meanwhile is due to the specialists operating this ore since years, very, very good in terms of CCS separation, also energy consumption and capacity of the plants. In the future, to change, of course, there will be some more action needed. Better classification and blending. We heard it also, beneficiation, production of iron ore concentrates, and all these things. Of course, optimization of the heat cycle and green pelletizing. Our, Prime Metals or Siemens VE, our portfolio is, we have the straight grade pelletizing technology. We have granted the Metso license with the 13 references in India. We can also offer this Lurgi-based technology, which is quite very similar. Of course, there are some mechanical differences. In principle, the process is not completely different. And what we have done, I mean, everybody knows maybe it is the CPT plant for small capacities from 0.5 to 1.8 million tons per year maximum. Of course, we know in India, fuel use, there are not only pelletizing plants with natural gas running. So we have this mixed gas, if it's COG, if it's BOF gas, of course. We are working on this. We are offering this advanced level 2 automation features, and we have our own eco in-house solutions. Yeah, what we are doing, of course, is new plants, revamping, modernization, and we do, of course, in our test center in Leoben, we are able to do this pelletizing test work from beneficiation down to the smelted product even, so including beneficiation, pelletizing in our pellet pot. It was mentioned today, Newfer is doing tests with us for 2 projects of them, so we are executing those tests. Then we have all possibilities to do direct reduction and also then do smelting in different furnaces. So that's what about pelletizing. So what are we doing in the direct reduction? We have the Midrex license. So we are building these shaft furnaces with Midrex. And then we have our 2 fluidized bed technologies, the Hyrex and the Hyfor. We see all 3 technologies coming up in the future. All of those technologies will have their place. There are, for each technologies, advantages and disadvantages. For Midrex, of course, you need agglomeration, you need pellets. For Hyrex, it's based on hematite sinter feed, and Hyfor is, of course, based on pellet concentrate and any type of iron ore. All 3 technologies will work with high-grade ore, based on high-grade ores, operated then directly after reduction in the electric arc furnace, or on lower medium-grade ores, and then processed in the smelter, and then in the LD converter. Yeah, Midrex is the market leader. Also in India, India is the biggest direct reduction country because of these rotary kiln systems. This is a specialty of India, but also Midrex plants in India. We have 4 different plants built up in the last 2 since 2006. And the advantage of Midrex is the flexibility. It can operate it with natural gas, with hydrogen, in case of GSBL Angul, based on coal gasification. In GSW Dolby with coke oven gas addition, and Toranagalo, the compound with Corex, so based on Corex gas. What we see also in India maybe is, of course, CO2 removal will be an interesting thing. We have our in-house technology due to our mother company, Mitsubishi Heavy Industries, this KMCDR CO2 removal and amine-based removal. It can, of course, implement it in blast furnaces, but also in the future in the direct reduction plants. So this is the process. It's an amine-based process. We are Mitsubishi Heavy Industries. There is market leader and has running the biggest plant and able to capture up to 95% of the CO2 from the waste gas. So now the specialty of prime metals is our two fluidized PET technologies. The main difference is the feed material. The Hyrex is based on sinter feed. It's based on the Finex process, which is operating at POSCO, for example, in Korea. So sinter fines are then direct reduced. The Hyrex is a combination of the Finex process, but including this electric smelter. So there are sinter fines are reduced directly to a metallization degree of up to 85% and then direct reduced into the smelter and producing hot metal. So HYFOR is our latest development, still not ready. Here we are processing magnetite, hematite or goethite fines, concentrate fines directly in a two-stage process with a preheating cycle in cyclones and then a direct reduction in the fluidized bed reactors. And then in case of weak ores, processing in the electric smelter to hot metal, or in case of high-grade ores, briquetting and then processing either producing HBI or processing in the electric arc furnace. So only for a short, the difference between these two technologies is in principle the feed material. Both processes can be operated with hydrogen, or in principle hydrogen-rich gas coming in principle from electrolysis or from a steam reformer. Just a few pictures of the development. This is the demonstration plant, which is now engineered in Pohang and should go to operation in 2026. It's a 300,000 tons plant, producing 300,000 tons, 40 tons per hour hot metal in the electric smelter. And this is our pilot plant, which we are operating now since 3 years with good results. And the next step will be to have a prototype plant landing here at this first Alpine site in Linz in 2.5 years. So thank you. That's it from my side. Thank you very much.
Thank you. Thank you so much, Bernard. You know, one of the reasons why I had to put you and my good friend Andrin right at the back when the audience has come down is because I couldn't have put Danelli and Primetals together. Then, you know, I would be blamed that I am putting one darling against the other, you know, out of the two darlings. So that is why I had to put some space in between.
Okay.
And, you know, I always give my good friend Andrin, who also lives in Vienna, not very far from you. So he has a big advantage of doing the summing up for the entire day because, you know, he's a brother. He's my brother. I can give him the job of summing up what everyone has spoken about today. Okay. So Andrin, you have a very tough job ahead to finish off as the last speaker, but not the least, and sum up for everyone else to make my job easier. So over to you, Dr. Andrin Bhattacharya, CEO, Resiren. And by the way, Andrin spent a lot of time at Voestalpine Stahl. And he did his PhD from Leoben.
We know.
Yeah, I know Bernhard. Servus Bernhard, grüß dich.
Grüß dich.
So over to you, Andrin.
All right. So I think the job of summing up is not really very easy because there have been many people, many nice talks, and it might create a lot of professional conflict if I sum up all the things with Neufer and Primetals and Danelli all together. So what I would rather do, I have made a very small presentation. So to you, if it's all right, Mr. Mukherjee? Mr. Mukherjee?
Are you there? Okay, all right. I have a very small presentation, which I'd like to say about the agglomeration of iron ore, which our company has worked before. And later on, I was thinking about this to give a summary a little bit in a different way of the current iron ore financial and the trading situation that is prevailing right now in India. And instead of summing up technical things, I might sum up from that side. So I'm just sharing my screen. Yeah. Okay, so as you know, our company, wait 1 minute. Our company is located in a small city in Austria called Leoben. We will not go very much in detail. We have some small offices around the world. And apart from technology innovation and development, we are also involved into raw material sourcing and trading sectors. And we had some patented or proprietary technologies for us, especially when it comes to waste recycling, because the company that started Resiren started from recycle plus iron, so which was actually aimed at producing DRI from raw material wastes from steel plants. Then we gradually moved one step apart and took iron ore tailings, low-grade iron ore, and if there is sufficient iron ore content in red mud, which is the waste product from raw materials, waste product from bauxite refining from the aluminum industry, because that also have 50% to 55% iron oxide inside that. So I will not go very much in detail in the process of Resiren. That is essentially a process based on cold briquetting followed by followed by reduction inside rotary kiln, where we had a patent, and making DRI out of that, which looks like this, depending on your raw material value, the raw material component, 75 to 81.5% of metallic iron, which is pretty good to put inside in your electric arc furnace or even in the blast furnace, because you know, if you charge 1 ton of DRI in blast furnace, you save around 400 kilos of coke per ton of DRI. So this is our little pilot plant that we have hired in cooperation with a company which is called ARP in Leoben, where we have demonstrated our technology. Now let's go to today's subject, which is tailings and red mud to DRI. Now, we all know how dangerous red mud and iron ore tailings could be. We know everybody what happened in 2019 in Brazil. We all know about the Brumadinho disaster. There, particularly the part of the mountain, the dam got broken. 40 million tons of tailings got released into the environment. The local ecosystem got completely destroyed. The same thing that happened in Aika red mud spill in aluminium in Hungary in 2010. And there 3 million tons of tailings were released in the environment. And a lot of people died there also. However, the main interesting thing is what caused actually the problems there is nothing else but free iron ore, as simple as that. So we decided how to utilize this free iron ore inside it, because iron ore tailings, you got 52, 53, 54% iron at the most. Iron ore and red mud, there is also a lot of iron. So we are today concentrating on two things, iron ore tailings and low-grade iron ore in India, which is very important. So let's review a little bit the challenges and opportunities in India. First of all, there is a huge tailings deposit in all the iron ore mining belts in India, which is either untouched or almost at the end of its capacity to be filled up. Then also, this subject is not very much taken up today, so that's why I'd like to get into this. Previously, India has been a huge exporter of 57 to 58% of iron ore fines to China, which were essentially used for the Chinese sinter plants there. And there have been millions and millions tons of export to China before, but right now, with Chinese steel demand going lower, and they are also trying to mitigate their carbon footprint in some other ways, this particular material is not getting used in the way that we have seen before. And that actually has put the merchant miners at a cross, because they're sitting on humongous stockpiles of 56 to 57%, maximum 57, 58% is the cap, because that's also another problem set by the Indian government, that you cannot export iron ore, which is over 58%. And otherwise it attracts a humongous amount of duty, which renders it not competitive at all. So these two things, first of all, we have abundant low-grade iron ores in the country, which right now is not getting its market in China. Only a few shipments right now in Paradeep and Vizag. There is at least 500,000 tons of iron ore simply waiting to be sold, but there are no buyers. And secondly, we need, of course, alternative agglomeration technologies, because one particular thing in India that we always tend to overlook is India is possibly the only country in the world where the large percentage of the steel industry is actually held by not large conglomerates, but rather medium-scale entrepreneurs. And they are very, very important to the ecosystem and their entrepreneurial spirit, because in most of the other countries, steel industry is something which is normally dominated by large conglomerates, with the exception of India, where the MSME sector in steel industry plays a huge role in the production, especially more than 50% of the 28 million tons of DRI that's produced in India is produced by the MSME sector. So for them to get into an innovative and a newer technology, lower capex processes are required. So that's why we have patented a technology, which is here. You can also see red mud, but if you see on the left-hand side, this iron ore tailing side is much, much easier, because inside red mud, if you just put simply iron ore fines, iron ore low-grade fines or tailings, dry it, make some, we have some patented binders and additives. And then if you reduce using rotary kiln, you will get commercial grade DRI using this process, which you can either sell to the market, put it into the electric arc furnace or induction furnace. In Indian context, I'm not going very much into the technical details today, because although I know the only few people who are still now are possibly the greatest connoisseurs of DRI and agglomeration and pelletizing, but this is something might be the technology, detailing the technology with the numbers might be a topic for the next presentation sometimes later on. So here we have a very, very fast return on this technology. You can produce DRI directly from tailings and low-grade iron ore without the need of pelletization. And so in parallel, you can reduce catastrophes caused by dam breakages and fine dust pollution. Also, there are some, it's a little bit, the numbers a little bit old, because you can see I have calculated DRI sales price to be 350 euros per ton. Right now in India, it is something between 370, 380. Also, the coal price got increased last year, again came down this year. So there is a change in the price, but at any point of time, the internal rate of return, IRR, of this process is above 50%, because of you have a very low capex, and you have your starting material is iron ore tailings and fine low-grade iron ore. They cost almost nothing. So also a very, very low cost process in terms of both capex and opex. Our technology got a few awards and accolades there. And just to end up, I might share a couple of my thoughts. As Mr. Mukherjee said, that of course we know there is a global pressure from the green lobby in terms of decarbonization in the steel industry, but sometimes in the name of decarbonization and hydrogen, sometimes we forget that the two things that are governing any kind of chemical industry are thermodynamics and chemical kinetics. And whatever you can do, you cannot get against these two, even if you want to badly. So we have to be two things. We have to be pragmatic because India is not considered by the first world as a first world country. It is still considered as a second world country. And if you check the emission per capita, India simply doesn't come maybe in the top 25 in the whole world. So, and the more and more we try to pressurize the local steel industry on the name of decarbonization, we are actually forcing the MSME industry we are pressing them against the wall to fulfill certain criterion, which a country as in India, the total emission per capita may not be that much relevant. And we are pretty much trying to break the system, what used to be in India in terms of a profitable iron and steel industry, and trying to deviate in some other way, whereas the thermodynamics and kinetics do not fully support this process. And of course, there would be debates according to this. Now the global trend is decarbonization. So from the political agenda side, every government has to follow. But my suggestion is India is really, really lucky to have a lot of resources in the country, and a pragmatic usage of those resources along with the greater good of the people is much more required that we need. So that's my 2 cents on this webinar. I see 13 attendees and 8 panelists, so 21 persons, all possibly the greatest connoisseurs of in this subject. So that's all from my side.
Thank you, Andrin. We started with 90 plus, and we are ending with just 21. But anyway, that's how all the 49 webinars that I have done so far, I always find that after 2 hours, the audience starts sliding. So there is nothing much that I can do. If I need to have a good spectrum of panelists, it goes beyond 2 hours. And it's difficult to, keep it within a very thin timeline to finish within 2 hours. But anyway, we spent almost 5 hours today. 3:30, which is, if I go with the Central European time, it was just at the stroke of midday. We started at 5 and ending at almost 5, which is almost a day's conference. But I'm grateful to Mr. Naveen Lobo for having stayed this long. I'm grateful to my friend Soikot, Bernard. Soikot, thank you so much. Thank you, Andrin. Thank you, Mr. Indrajit Paul. And thank you, Mr. Lamke. Is there anything that anyone would like to add as final comments?
Mr. Mukherjee, I would like to give a suggestion. Probably instead of starting at 3:30, we could advance the time, probably immediately after lunch around 2 o'clock. So that would give us a window of almost 4 hours to 4.5 hours, normal working hours, where the audience, instead of dropping to 20, as we are telling, could be staying up to 50.
Yeah, but the only challenge is, Mr. Lobo, when someone joins from US, or if, because I was not quite sure whether Bernard, whether Mr. Lamke would be there from Brazil or from, I did not know he is from Germany. I always had a feeling that Haver and Becker would be addressing from Brazil. So, I had to keep a time slot, which would not be, middle of the night for people down in South America or anywhere around in the west coast of US. So keeping that in mind, I always choose a time slot which is convenient both for the East and the West. If someone has to join from Singapore or someone has to join from US, both can do that. That's the only challenge I have. If I would be in London, perhaps life would be a little easier. One of the things which was asked to Lakshmi Mittal when he decided to, about almost 30 years back, he moved to London. One of the things journalists used to ask him all the time is, why did you choose London as your headquarters? He said, my first half is for the East and the second half for the West. First half for the West and second half for the East. So that is why he chose London as the headquarters. Even Primetals, I'm sure Bernard would agree. I don't know if he's there, but Primetals chose London as the headquarters only because of that reason. One more reason, of course, being that the Japanese wanted a cosmopolitan city as their headquarters. They didn't want links. So that's why, they thought because the Japanese, if you look at Japanese culture, they normally like to stay together. So they thought, a better Japanese community would be in London, and they chose London as the headquarters. This is just my thoughts on the subject. Andrin, am I right or wrong?
Of course.
That's the reason why they chose London as the headquarters instead of having Linz at the center of competence. So I suppose your point is well taken. If you could start a little earlier, people would be there in office, because otherwise, once it's beyond office hours, it's difficult for them to stay connected.
But normally we don't have American participants that much, right?
Yeah, but if you remember, Shoboda used to join during his days in Big River. Shoboda always used to join from the US.
Yeah.
So, at times early in the morning, he would join 6 o'clock in the morning. So that was a bit of a challenge. But anyway, what we will do is I will try and advance it by at least, hour and a half. So we start at 2 o'clock, as Mr. Lobo said. 2 o'clock would be a better time, and 2 to even 6 is fine.
Right. Also, Shoykot, it's good to see after you for a long time.
Yeah. I met Shoykot last month in Germany at MITEC. So, I introduced him to my son Ankit also. So he met my son, and in fact, Shoykot came with a colleague from Pakistan, who also knew my son's friend, who is a film star in Pakistan. So my son, in fact, got a chance to interact with Shoykot for a long time. So I think Shoykot came with around 4 or 5 colleagues in Germany.
Yes.
Yeah. So, all right, I'm dropping out from 5 o'clock. I have another thing scheduled.
Yeah, we are exactly 5 hours from when we started. So with that, I say ciao to everyone.
Yeah.
And
Yes, bye-bye.
Everyone, wonderful week ahead, and take care. Let's keep in touch.
Thank you. Bye-bye.
Bye.